of the National Science Foundation to deliver the welcome address. Over to you, sir.
Good morning. Representatives from our Board of Management of the NSF and also the members of the steering committee on the climate change and natural disasters and the project leaders, other team members, and also other invitees from our government and non-governmental organizations and also academia. Very good morning to you, and I warmly welcome you all for this closing session of the National National Thematic Research Projects on Climate Change and Natural Disasters. What I heard is that this project has been started as long as 2017, almost 10 years ago. Due to several reasons, including COVID, this has been dragged on some, and also because of the economic constraints, some of the projects has to be curtailed or to abridged in a way that is not delivering the exact results. But anyhow, that we are happy to be here, finally concluding all the five projects with successful results. So it is very important that NSF is funding for important research for the development of the country and also its people. So with that we have that identified the funding for this climate change and natural disasters is a very important and timely decision. And it is very much evidence with what we are experiencing today. Last year we experienced one extreme with Ditwa, with the natural disaster. This year we are just beginning to experience El Nino, the other extreme. So with those things, the importance of this research thematic areas and also dig into the problems, identifying solutions, bringing solutions to the, bringing results to the community is very much important. So I hope that this meeting today will be a very fruitful meeting with interactive discussions about the results and to implement the findings in our day-to-day work, and also our national policies will be hereafter. It will be materialized, that I hope, and I expect your active contribution and participation in this forum. Thank you very much.
Thank you very much, sir, for your inspiring remarks. Now I would like to invite Ms. Dilani Jayveer, Coordinator of the National Thematic Research Program and the Scientific Officer of the Research Division, to provide an overview to the National Thematic Program on Climate Change and Natural Disasters.
Thank you, Sureshini. Good morning. So today my task is to give an overview of what we did through our National Thematic Research Program on Climate Change and Natural Disasters. Actually, National Thematic Research Program was an initiative we had in 2010-11, back when then Board of Management identified that national research priorities should be addressed in a different manner to our investigator-driven or principal investigator submitted the research program. We call it competitive research program. With that objective, they initiated the National Thematic Research Program and identified 4 areas, that is food security, climate change and natural disasters, water security and energy security. Initially, we developed a theme paper. This program is a mission-oriented, multidisciplinary, collaborative research program with a view to address national needs and to drive the national research systems to produce well-defined outputs. Actually, these outputs were identified by the NSF through a theme paper, which is a very comprehensive document developed by the steering committee and the NSF. Our national thematic research program on climate change and natural disasters, we had this kind of a theme paper, and it has 7 strategic thrust areas. And under those areas, we identified 15 projects. These were the strategic thrust areas and the projects that NSF identified as important to do research on. So we were able to award 5 projects under these 7 thrust areas. Actually, we had projects only on 4 thrust areas, and food security aspect of climate change, that is minimize climate change impacts on food security, were addressed under the food security program. 2 areas we couldn't get sound proposals to give grants. Once the theme paper was developed, which was a very comprehensive document, which is still available at the NSF, we advertised that theme paper in the NSF website, and we went for the 2-way application process. That is, we initially call for expressions of interest, then we call for full proposals. We received 41 expressions of interest, and those expressions of interest were screened by the steering committee and the NSF. And we had first screening, second screening, and then shortlisted applicants were asked to do presentations. The applicants who succeeded in presentations were called for full proposals, and then the evaluation of full proposals were done according to NSF criteria. Actually, it was done by an independent reviewer and the steering committee as well. Then all the full proposals were presented at the first research coordination meeting. We had a meeting like this, and the steering committee stakeholders, possible project proponents were all there. And we had first research coordination meeting. After that, we had steering committee meetings, several steering committee meetings before awarding grants under 4 thrust areas and 5 projects. After awarding the projects, what we did was we monitored the projects. Then the presentation of progress and next year work plan were done at the research coordination subsequent research coordination meetings, 2nd, 3rd, and 4th. Monitoring was also done via field visits, progress review meetings, research into practice program, and today we are having the final research coordination meeting. We had the help from our steering committee throughout this tedious process. The steering committee was chaired by Professor W.L. Sumathipala. Our committee members are here: Professor Shanti De Silva, Dr. Punyavardhana, Dr. Mallavantantri, Professor Buddhimarabe, Professor Vijayatunga, Mr. Premalal, Dr. Arnalantan, and Mr. Samarakodi. They were with us through these 10 years in thick and thin in completing this program successfully. Today's meeting is to complete our program. We are going to close all the projects here. Today will be the final presentation. Then we have to submit a full report to our NSF Board of Management. And with the final reports of the projects and the NSF final report on the program, we will be wrapping up our thematic program on climate change and natural disasters. And we would also like to promote a dialogue with key stakeholders about our research findings that the project leaders will be presenting today. Some key outputs, because I'm not going to elaborate on research findings, they will be elaborated by the respective grantees. We had publications, capacity building were done, and quite a number of data sets which are very useful have been generated through this program. We faced several major constraints: COVID, economic crisis, and then we had fuel restrictions. All things got escalated with the price with dollar fluctuations. Then we had procurement issues, and strikes and union actions in the universities also affected our program severely. So this actually, as I informed earlier, this program was little bit different to our competitive research program. The projects were identified by NSF. We gave initial funding for only 6 months, and depending on the satisfactory progress only, we gave funding for the next years. And we had research coordination meetings and very close monitoring, one-to-one interviews, field visits, progress reports, and progress reviews were done by the steering committee and the NSF. And we appointed 2 steering committee members as advisors to each project, and they have been with the projects throughout the program. So that's what we did through our time period. So though it got delayed to complete, most projects were completed by 2022-2023. Because one project we awarded in 2019, we couldn't complete the whole program. We had to complete it as one program. That's why the RCM got into 2026. Otherwise, we would have wrapped the program. The 2019 project, we had to give it some time to complete the activities. So thank you for listening to my presentation. Thank you.
Thank you, Ms. Dilani, for presenting the background and objective of today's program. Now I have the pleasure of inviting the chairman of the Steering Committee on Climate Change and Natural Disasters to address the gathering. Professor W.L. Sumathipala has joined the meeting online from Australia. So over to you, sir.
Thank you. I hope you can hear me. Can you all hear me?
Yes, we can hear you, sir.
Okay, thank you. Good morning, even though it is afternoon here. Professor Sudat Samaravira, Chairman of the National Science Foundation, members of the board of the National Science Foundation, Engineer Disanayaka, Head Research Division, Ms. Dilani Jayavira, who spoke now, and the staff of the NSF, members of the National Thematic Research Program on Climate Change and Natural Disasters, project leaders, team members of research groups, ladies and gentlemen, welcome to the final research coordinating meeting after a long lapse of time. Thank you, Dilani, for a very clear and extended explanation of National Thematic Research Program. Now, it is a privilege to have the opportunity to speak to you, even if only remotely, as the chairman of the Committee on Climate Change and Natural Disasters Program. NF was providing grants to scientists when they submitted their research proposals. Essentially, even funds were provided to NSF from government and ultimately from taxpayers. Research was not directed anyway. It was largely driven by individual research interest of scientists. Proposals were evaluated, selected, and funded on the basis of their scientific merit. However, for some time, there had been discussions about whether the NSS should play a major role or active role in directing research. Idea was to direct research into areas that could contribute to the development of the country, solve natural problems, or aid national development. Instead of research priority being determined by individual scientists, the NSF would identify important national needs and direct research toward those areas. The fundamental consideration was that, as a developing country, when a taxpayers' money is involved in research, there should be a value for money spent. Research should not be generated scientific knowledge, but where possible, also provide benefit to the country. This was the thinking behind the National Thematic Research Program. Those days, the usual practice at the NSF was to call for research proposals, evaluate them, provide grant funding. There were no systematic assessment of whether the research directly contributed to the national development. This is not to say that the research lacked scientific importance. Success was immensely assessed through scientific publications and perhaps the production of postgraduate students. Only rarely research progressed towards patent or other form of practical application. To develop thematic research program, the NSF had to think carefully about
Recording
the
in
areas
progress.
that should be prioritized. First topic of NTRP was food security. Climate change was hot topic those days, I guess even now, and its effect is felt almost in all sectors. It was well documented that tropics are the most vulnerable to climate change, and Sri Lanka was one of top of the list of countries that will be significantly affected. As such, climate change was one of the several topics initially considered. Climate change is, of course, a very broad subject. Therefore, natural disasters was added to narrow it down. So the theme became as climate change and natural disasters program. The process began in 2016, as you all know now, with call of expression of interest under 7 subtopics. As you know, 43 EIOs were received. After careful screening, full proposals were called. 5 projects were initiated with partial funding in 2017. The main idea was to find scientific understanding and prepare recommendations for policymakers to direct action to overcome, avoid, or at least to take precautionary actions early on natural disasters and their effect on the country. I am happy to say that we had a committee of mature and highly experienced team of experts. Some of are there now. They were all senior professors or senior officers of reputed agencies. They expressed their views frankly and without bias. They all contributed enormously to reviewing, guiding the program. As the chairman of the committee, I must thank them for their untiring work in the committee on behalf of the NSF. At that time, many talked about climate change and many became climate change scientists. It was rapidly developing field. Just as today, we have many researchers working on El Nino. I consider this a positive development. I remember in 2014, NSF published a special edition of the NSF journal about El Nino, and I recently found that its editorial was written by me. In the final paragraph, several important ideas were highlighted, but nothing happened during the last decade on El Nino research in the country until another severe El Nino is about to arrive. Getting back to the thematic research, the funding provided for those projects were considerably greater than that was available through regular research grants. Another important feature of the program was it was multidisciplinary in nature. Climate change is not confined to a single discipline. It is a cross-cutting issue requiring expertise and approaches from many different fields in order to conduct proper investigation. Therefore, it was decided that those problems should be investigated by a group of scientists with different backgrounds and expertise. Today, you will be able to listen to the final presentation by the team leaders and members of the teams. It will be possible to see the areas and subtopics where research were conducted. You have the opportunity to judge the research findings. I have my personal view on that point, but this is not the time to elaborate on that. The big question will be to see if we were able to receive products which are justifiable for the money spent. As you are aware, during that period, NSF and of course Sri Lanka had some financial difficulties and there were some delays in fund disbursement. I have no idea about the present situation, about the fund situation at the NSF. Chairman will know. I am a scientist. I hope funding have improved and increased. As we all agree, scientific knowledge is most important for development. No other country or agency will conduct research on our national problems. Now I am going to express my frank opinion here, through some may not, even though some may not be agreeing with me. Proposed budgets were overestimated and NSF was unable to provide timely funding. Not only that, projects were delayed due to many other factors. Some had problems with university accounts divisions. Of course, Dilani explained other problems. All these factors dragged the projects and in many cases cost increased with time. You will see in many projects granted budget sometimes less than the half the estimated. It is now today for you to decide after listening to the presentation whether the NSF and ultimately the country has received outcomes that are useful and valuable. If that is not the case, then we have to seriously consider what went wrong and what steps to be taken in order to improve the process in the future programs. On funding amounts, projects number 5 and 2, both agriculture faculty Peradeniya, topped the list amounting to over 17 and 14 million. Next was from University of Runa over 11 million, and the other two were Wayamba and Morot were around 6 and 2.5 million respectively. I am not sure whether the universities and departments involved in climate change research applied for this national call for EOIs and were not selected, or whether they did not apply at all. None of the scientific agencies and departments in the country, other than the universities, applied for this national call as well. I must mention that unlike other projects, the committee took an active interest in the progress of these projects. We visited universities, reviewed their progress, and helped the process. So the NSF initiated thematic research program 16 years ago, and climate change and natural disasters project started after 6 years in 2016. So we conducted these final discussions after how many? 10 years or more. It's after its inception. I am permanently out of the country for the last 7 years. I am not aware the thematic research program is continuing or other programs have started at the NSF. Finally, I would like to thank those who worked together with me, the committee members, the NSF staff, and the researchers. I'd also like to thank everyone present here today, as well as those who were unable to attend but contributed to the program in various ways. A very big thank to you, the organizing committee, for giving me the opportunity to speak to you today. I may have taken a little more time than was allocated, which was 10 minutes, I guess, but I apologize for that. Thank you very much. That concludes my presentation. Thank you so much.
Thank you, sir, for your valuable insights and guidance provided throughout this program. We really appreciate it. With the completion of 5 significant research projects under the National Thematic Research Program on Climate Change and Natural Disasters, we now have the opportunity to hear directly from our team leaders. Let us listen to the project leaders as they share their key findings, achievements, and contributions to this thematic area. Our first presentation will be delivered by Professor Pradeep Nalaka Ranasinghe of University of Ruhuna on understanding the long-term influence of Indian Ocean, warm pool and Indian Ocean dipole on the monsoon variability of Sri Lanka. Professor Ranasinghe is joining from online from USA. Over to you, sir.
Can you hear me? Hello, can you hear me?
Yes, sir, we can hear you.
Okay, thank you very much. I cannot share my screen. It is disabled. Can you please enable the sharing the screen?
So now the settings are okay from our side.
Still, I cannot share it. It says host disable the participant screen sharing.
Okay, so give us a few seconds.
Okay.
So now,
Oh, now I can do that. Yeah, thank you very
yes.
much. Very good morning, all of you. Chairman NSF, board members and staff of the NSF, and Professor Sumatipala and the steering committee, and invitees. Thank you very much for giving me this opportunity, especially at my request, considering the time conflict. It is midnight for me. It is like 12:45 a.m. So first of all, I should thank NSF for funding this project. And as Dilani and Professor Matipala mentioned, we face a lot of hardships. And it started with the Easter bomb attack. The ships didn't come to Sri Lanka for sampling, and funding issues and everything happened during this time. But I should thank my collaborators, foreign collaborators, and they came up with funding and providing other facilities. Thanks to them, I could successfully complete this project. Actually, we did more than we expected. I will explain you what we did so far. So our project team is, this is our project team. Actually, most of our project team members are now retired. And even some foreign project team members are also retired because it is now 10 years. And Professor Hevasam is there. He is the only one. He is now chairman, Central Environmental Authority. And the original duration was 3 years, and the allocation was, as Professor Sumatipala mentioned, 11 millions. But we returned some money because of the issues. Okay, so actually this research basically planned to look at the Indian Ocean worm pool, how it varies and how it impacts the our precipitation, the monsoon. So I will give you a brief introduction about Indian Ocean worm pool. The worm pool is defined as 28 degrees centigrade isotherm, the temperature contour in the ocean. So if you look at this map, so you can see Pacific Ocean and the Indian Ocean worm pool. And Indian Ocean worm pool has expanded during last 120 years. So it was double in size. And so we will talk about that later. So this actually the worm pool is very important because when the temperature is above 28 degrees, the evaporation is high. And as a result, it helps precipitation and it contributes to monsoons. So that's why we want to know how this worm pool change through the time. So we know that the Indian Ocean worm pool change in size annually. It expand vertically and laterally. So that means vertically and laterally means it expands longitudinally and latitudinally. So it's annual variations. Also, it changes in size depending on El Nino and La Nina conditions. So we know these variations. We know these variabilities because these variabilities are usually decadal scale mostly or annual scale. We know these things because we have records for last 50 years. We have temperature records in the ocean, mostly through satellites and also some instrumentation. But this 50-year data is not enough to fully understand the cycles of this monsoon variability or the worm pool variability or anything. So therefore, we need longer records. That's why we try to reconstruct the long-term variability of monsoons. Now, one thing I have to mention you that now we all have climate data for last 100 years, most of the time. Precipitation data, temperature data, we have. But we don't have records older than that. We have historical records. But the most important thing we have to understand is our climate cycles are not only decadal scale. Some of them are centennial scale. Some of them are millennial scale. So when we are doing climate modeling, we have to consider all these long-term variabilities to predict, to model climate changes accurately. So without having understanding about long-term climate changes, centennial scale, millennial scale, climate changes, the cycles, we cannot do this. So therefore, we have to collect data over 1,000 years. Okay, so that's why the scientists are trying to reconstruct climate over a long period of time. And at the same time, we have to understand how our oceans behave throughout a long period of time. So that's why this project came into exist. So we wanted to see how the Indian Ocean temperatures have changed through the time. So we didn't have any long-term Indian Ocean temperature records. People have collected data, but there was no any compilation or anything. And there were many gaps in the locations. So therefore, we try to develop the model, the temperature variability over last 100,000 years and see how these changes have happened in the temperature, because that is related to monsoon variability. So that's why we developed this project. And mainly the objectives of this project are to understand the warm pool variability and the Indian Ocean temperature variability over 100,000 years. And we try to reconstruct, we try to understand what is the relationship between warm pool and the precipitation in Sri Lanka. And also we try to understand what is the factors behind this variability. And also we want to study what is going to happen in the future. Okay. So these are the main objectives. I will briefly explain what we did. Okay, so I'm not going to explain the methodology, but I will explain briefly what we did. So when we are doing this, we had 3 strategies. One is we wanted to collect all the existing temperature records, long temperature records in the Indian Ocean. And for the gaps, we want to make new records. So actually now you might think how we are constructing these past temperature records. So we are using foraminiferas living in the ocean. Using foraminiferas, their chemistry, their magnesium-calcium ratio can be used to reconstruct the ocean temperature in the past. So that is what we did. Now, we reconstructed the surface temperature of the ocean. That is the most important, because surface temperature contributes to the evaporation, and that is driving the precipitation. So therefore, we reconstructed the surface temperature records using foraminiferas live in the surface of the ocean, surface layer. So we use a magnesium-calcium ratio of the foraminiferas. That is a long process. And we did all the preparation in Sri Lanka and analysis in Germany. And we developed age models, and age models were developed mostly in the US. And so that's how we did that part. And after that, we prepared the temperature maps. I will show you them later. And so then I told you that we try to correlate our monsoon record with the ocean temperature records. For that, we wanted to reconstruct the precipitation record. So for that, we had already collected one sediment core from a gem field in Ratnapura. So that record goes back to 80,000 years. So we developed that, using that sediment core, we developed 80,000 year precipitation record for Sri Lanka. So that is the longest and highest resolution precipitation record in South Asia. So actually, that was also done because of the funding of some other institutes, especially in the US. And so we developed that. And so that is now we have a ocean record, temperature record, and we have a precipitation record. Now, all these sediment records, now ocean sediment records, they are low resolution. Low resolution means using sediments, we cannot tell temperature variations less than within now usually 100 years, 200 year time resolution. That is the minimum time resolution we can go using sediments, because sediment accumulation rate in the ocean is very slow. So therefore, we cannot develop any record more than 100 year or 200 year, sometimes even 500 year in some areas resolution. We cannot go higher resolution than that. But luckily, our Ratnapura monsoon record has very high resolution. It has, in some areas, in some period, it had 13-year resolution. We can tell the temperature variation, rainfall variation at 13-year intervals. So that is the unique character of that Ratnapura sediment core. So therefore, actually I wanted to see how ocean temperature variations happen at high resolution. That means less than 100-year, 200-year resolution. So with that, so then I was looking for methods, and then I realized that we can use corals. And corals record temperature, ocean temperature, we can get data at monthly resolution, because corals are growing at about 1 centimeter per year. So therefore, we can develop records at monthly resolution. So that is the beauty of coral. So we added another part to this project. Actually, it was not funded by our project, and I used that data, and it was fully funded by Woodsole Oceanographic Institute, USA, because I'm a visiting scientist there. And so they help us analyzing all this data. So therefore, that added another dimension to this project. So again, using corals, we can use coral strontium calcium can be used to get the temperature of the ocean. So this is the equation. So these are the foraminifera. So we use this rubus, Globigerina ruber, and to get the magnesium calcium based temperature records. And so we use marine sediment cores, and we collected a couple of them. We plan to collect more, but we couldn't do that because government policies, and they restrict foreign vessels coming to Sri Lanka, and we miss most of the planned research crews, because actually the Germany and Korea, they offered us for this project, and they supported, and so they were willing to China, they were willing to did sediment coring in our area, because they were collaborators for this project, but the government decided they didn't allow any foreign vessels to come to Sri Lanka during the last 5 years. And so we missed most of them after the East attack. So unfortunately, but what we did was then we collected samples from already collected sediment cores in Japan and also in the US. And I used those sediment cores, previously collected sediment cores for this project. And so we did that way. And for the corals, we did coring of corals. And so we did drilling and collected coral cores. And don't think that it will damage the coral. It doesn't damage. It is only like 2-inch diameter coral core. And then after that, we cap the coral. You know that coral is live only in the surface. And even this coral we sample, that is a dead one. So we sampled 2 corals at Valigama and in the Pigeon Island area. So after capping, it doesn't do anything. Okay, so these are the locations we used to reconstruct the temperatures, and these cores we collected, and we used this. We reconstructed new records in this sediment cores. And these are some of not all of them, some of the cores we used to reconstruct the temperature. Okay, so I will show you what is the outcome of this temperature variability records. So first, if I summarize, we understand that the Indian Ocean temperature is mainly driven by the solar insolation. That is the key outcome. So if you look at the history, so this is the solar insolation variability. Okay, so this is the solar insolation variability. And so you can, these are the cold periods, MIS2 and MIS4, and these are the warm periods. This is the last interglacial, and this is the present interglacial. We are living in the present interglacial. This is the last glacial maximum. So you can see the temperature variations, mean temperature variations in the Indian Ocean during last 100,000 years. Now, if you look at the last interglacial and modern, so they are the highest. And so in between, we have low temperatures. And so this is how insolation and temperature correlation. You can see that temperature is nicely correlate with the insolation, except last 5,000, now actually, so the after last 5,000 years, the trend is different. So the reason is actually anthropogenic impact. So after that, we constructed this kind of temperature records for different time slots. You can see this is for the last interglacial, and this is for the MIS5, as I showed you earlier, and this is MIS4, MIS3, how the temperature variation. So these are the temperature values. You can see the color bars. And so you can see during last interglacial, it was warmer, and we had a warm pool. And now I told you that Indian Ocean warm pool is when the temperature is above 28, it is called as warm pool. And after last interglacial, we didn't have a warm pool. We don't have warm pool in any of these periods. So this is the previous warm pool, okay? And you can see now we are getting into cold last glacial period, last glacial maximum. You can see during last glacial maximum, there is actually we can say this is a dipole, negative dipole, and strong, and it is very cold here. After that, our modern Indian Ocean warm pool start developing at about 14,000 years. And now we are having a strong warm pool, and we know that it is fluctuating annually and depending on La Nina and El Nina. This is how our warm pool developed throughout the time. And so this is the first time that we understand how our warm pool variation happens throughout the time. Now, let's go to our rainfall record, precipitation record. Actually, this precipitation record is again, this part of this is from the Ratnapura sediment core. I told you that's from the gem field, and other part is from another sediment core we collected from the ocean as well as from the marine sediment core as well as from terrestrial sediment core collected from Gavaratan. So this is the record, but there is a gap in between because this core ends at 40,000 years and this one start at 30,000 years. You can see rainfall. If you look at the precipitation, this is the color, red color variation represent iron, and this is the chemistry, and again it represents the terrestrial flux. You can see high rainfall is found in warmer intervals. Okay, so this MIS3, MIS1, and MIS5 are the warmer intervals. Insolation is high, solar radiation is high, so therefore our precipitation is higher during those periods. And then precipitation goes down during cold periods. So that is very clear in this diagram. Now this is corresponding with our Indian Ocean temperature record. You remember that MIS5 we had the warm pool, and now we have warm pool. And when we have the warm pool, our monsoon is intensified. When we don't have warm pool, our monsoon is not that active. So I will go to. So there is another important thing. So if you look at this record carefully, you will see that there are small fluctuations. What are these small fluctuations? Those are very important. Some of them are abrupt climate events. So we have many this kind of abrupt climate events. These are driven by North Atlantic ocean conditions and usually northern hemisphere climate events. So if you look at this northern hemisphere climate events, so these are not affecting the Indian Ocean temperature variability. That is the most important thing. these abrupt climate events in the Northern Hemisphere or Atlantic doesn't affect our Indian Ocean temperature variability, because I'm not going to show you all these diagrams, but I made all these diagrams for these different periods, and it is in the final report. If you have that, you can see that. So these events don't affect our Indian Ocean temperature record. So you can see that if you look at this, all these events are in MIS1. There are some warm events and cold events, but temperature has no much significant difference. And all these are in MIS4, for example. So there is no much difference in the temperature. So that means there is no significant difference in the temperature in the Indian Ocean, depending on the Northern Hemisphere or Atlantic climate events. But so the interesting thing is all these Northern Hemisphere or Atlantic climate events have affected our precipitation. So you can see these blue areas showing you high rainfall events, high rainfall periods. Now these red areas shows you the dry periods, arid intervals. And so this is the time scale, 40,000 to 8,000, 80,000. This is 0 to present to 30,000. You can see there are many such events in our record. These two are our records, and these are other regional records. So now this is the first time we are recording these kind of events in our region. And so that means our climate, these events are coming to Sri Lanka, our region, through teleconnection, atmospheric teleconnection, not through the ocean. Ocean doesn't have change, but we are getting this impact of this North Atlantic and Northern Hemisphere climatic events through the atmospheric changes. It is mainly because of the ITCZ, the Intertropical Convergence Zone migration, and that is the main reason for having this kind of changes, not through the ocean. And again, another very important thing we found using this record is our rainfall. You can see high rainfall events and low rainfall periods, but this rainfall, the driving mechanism has changed through the time. So it is not always monsoon. Now we know that, I told you that the monsoon was active during the last interglacial and the present interglacial. So in between, the monsoon was not that active. The reason is warm pool. Now, if you look at this carefully, you can see during this period, this is MIS4 mostly, and the dominant rainfall mechanism has become, you can see this October insolation curve correlates with our rainfall record. It indicates that our rainfall was mainly driven by second intermonsoon. Why second intermonsoon? If you look at the ocean temperature records we reconstructed, we can see that temperature in the ocean was above 26 degrees at that time. So, now, but monsoon was not active. We think that it is mainly because of the cyclones generated from the Bay of Bengal, because ocean was warm enough to generate cyclones, but not the monsoon was not that active. And you can see during the glacial period, this is the last glacial maximum period, the precipitation records correlate with the April insolation. That means our first intermonsoon was the active dominant rainfall mechanism during that period. And after 14,000 years, as I mentioned you, that is the activation of the Indian Ocean warm pool, and the monsoon becomes the dominant mechanism. You can see now June insolation correlates with our precipitation. So that means our precipitation there was a different mechanisms dominated in our precipitation history during the last 80,000 years. So that is the very, very interesting thing here. It is not always warm the monsoon, but second intermonsoon, first intermonsoon, and the monsoon. And then we are getting into the high resolution rainfall record using rainfall and temperature record using corals. And this is the temperature record we constructed from Veligama coral, that is for the southwest. And you can see ocean temperature is gradually increasing. During last 50 years, nearly 50 years, you can see temperature has increased about 2 degrees. Okay, so that is one observation. And second one is, if you look at the rainfall, these are annual temperature variability. This is annual. Okay, so the coldest is usually December and January, and the warmest is like June, July. So corals are recording this very nicely. And this is the precipitation. Now this barium calcium ratio in corals indicate freshwater flux. Freshwater flux is precipitation. Okay, so that's how we get that. You can see if you look at the Veligama, there is a slight decrease in freshwater flux in Veligama area. That means the precipitation is gradually decreasing. Mostly our monsoon is gradually decreasing. If you look at the Trincomalee, that is the other coral, you can see there is a gradual increase in precipitation. This precipitation increase, I cannot say this is mainly because of the monsoons, the northeast monsoon, or could be mostly due to intermonsoon, because this is a cumulative thing. Because we can see that when we look at the rainfall month, we can see that it is mostly active. The rainfall is mainly coming from October-November season, because we can look at the monthly variability. Okay, so therefore we can see gradual increase. It is mainly because of, I think it is mainly because of the increase in the cyclone activity. And because you are interested, I'm going to show you some El Nino story from this record. Actually, after this presentation was set up, and I started looking at this data set again, and I want to see how the El Nino happened. These are the super El Nino events. And this is 23, 24, 15, 16, and 97, 90, 80, and 82, 83. Let's look at these events in our record. And if you look at here, you can see this is the Veligama coral. And you can see this red color is the precipitation, temperature. Blue color is the precipitation. This is our core, this coral has a record. It doesn't have 2014, 2015 record. So it has 97, 98 record. You can see this is the 98, and 97 is this year. And you can see there is a very the significant decrease in rainfall during the declining year of the El Nino. And this is another strong El Nino event. In this event, the El Nino, the temperature has gone above 32, but this 32 number may not be exactly accurate, because there is an error margin of like 1.5 degrees when we are using plus or minus 1.5 when we are using corals. And but you can see there is a increase in rainfall temperature in 92, 93. It's a strong El Nino event, but not super El Nino. But rainfall has not decreased. But if you look at the 82, 83, this is very significant. And again, this is the 82 and this is the 83. You can see there is a significant decrease in rainfall in the following year. That means declining year. So that means it is like this is our El Nino year, 2026, and 27 summer monsoon has decreased now according to these two records. And so that is another important observation here. And you can see this is another strong El Nino event, and the rainfall has decreased. The reason is Now, IOD also affect that. So this rainfall changes affect with other ocean conditions, not only El Nino. And so El Nino and together with IOD, it is decreasing and increasing. So therefore, there are different patterns, but two observations I want to show you is this 97, 98, and 82, 83. Both of them have decreased the summer monsoon or the next year declining year monsoon significantly. And now this coral record goes back to like 1944, and you can see this is another event, and it is in 1948, and it is not in our records. It is not recorded because there were no instruments, but that is another record we can get from the coral records. And if you look at the rainfall record in the Trincomalee, you can see this is 97, 98. There is no significant decrease in this one, but 15, 16 there is a little decrease. 82, 83 also like that. I have 2015, 2016 here, but we don't have 2023 and 24. 15, 16 is here. You can see there is a decrease, but other two, there is no significant decrease. That means even the summer monsoon or the southwest monsoon decreased during the coral, according to coral records, during the super El Nino events in the declining year. Northeast monsoon or the winter monsoon has not, we don't know whether it is exactly northeast monsoon. It may be because of the cyclones again. So the precipitation has not much changed. That is another important thing. And so finally, I have to tell you, this is a summary I told you. There was no iota Indian Ocean warm pool between last interglacial and 15,000 years. And there was a weak monsoon when there was no Indian Ocean warm pool. Indian Ocean warm pool is the driving factor for monsoon. And coldest ocean was recorded at last interglacial period, and there was a strong negative dipole during the last glacial maximum. So during that time, we had very low rainfall. And you can see the precipitation is increased during the warm insolation periods, and dominant rainfall mechanisms have changed with the time. And other thing is, you can see the short climate events have not affected the ocean temperature, but it has affected our climate record. And during last 5,000 years, precipitation in the southwest has decreased. That is mainly because of the IS, the Indian summer monsoon. And then if you look at the future, what will happen in the future? That is the most important thing for us. Now, we can see that ocean temperature is gradually increasing as a result, but the solar insolation is decreasing. Now, solar insolation has gone to the maximum, and now it is decreasing, and therefore, summer monsoon will decrease. And because two reasons, but because if the ocean, the thermal contrast between the land and ocean is gradually decreasing because of the ocean temperature increase because of the anthropogenic warming, and land temperature decreases gradually. So therefore, there will be decrease in summer monsoon or the southwest monsoon. And second winter monsoon, that means cyclonic activities will increase because ocean temperatures increase, and that will gradually become the main rainfall mechanism. Coral base record shows that there is a gradual increase in temperature about 2.5, and precipitation in the southwest decreases gradually and northeast increases, and significant decrease in precipitation in the southwest during the weakening year of the past strong El Nino years. But there is no significant decrease in precipitation in the northeast area. Those are the main research findings. And we have published that in Nature Scientific Report, one record. Two papers are in the pipeline, and so coral record and the ocean temperature records. And we presented these things many times in American Geophysical Union meetings, and so these are. And our one of our student completed the MPhil, other student left the country during the that 2022 after that event, and so there are a couple of students did the undergraduate research with this project. And actually, the scientific community, we had this results has a great influence on the scientific community, because this is the first Indian Ocean worm pool reconstruction in the region. And so also we have the longest high resolution precipitation record for the whole region. And also and coral-based high-resolution record in the Indian Ocean. We don't have anything. Red Sea has a record, but we don't have anything in our region. And so that will be very useful. And with the support of the NSF funding, we developed a marine geology lab at the University of Rona. And so that is another outcome of this project. And so for the national economy, and so this data, I am further analyzing this coral record because it has very important things, and we have to do more about the coral record. And this can be very useful. This will be very useful for disaster management and the agriculture and food security, fisheries, and things like that. And so actually the main thing we are going to do is I have to analyze further this data sets, and then we are planning to develop more high resolution long coral records with the support of Woodsole Oceanographic Institute. And also we want to add more SST records or sea surface temperature records to our map. So then we can, our map becomes spatially high resolution. So that is another target in the future. So those are the future works. And thank you, NSF, for funding. Also, I should thank Dilani and all the other staff and Professor Matipala for their help and guidance during the hard time. Also, all other institutes, Germany and China and the US institutes, for making this project possible. Otherwise, we will not be able to do this. Thank you very much. I am ready to answer any questions if you have.
Thank you, Professor Anasinghe, for that informative presentation on how the Indian Ocean worm pool and dipole affects the monsoon systems in Sri Lanka. Now we will open the floor for the discussions and questions. You may ask anything you want to clarify. And also the online participants are also welcome to clarify any questions.
Dr. Arul has some question, I think.
Yes, Dr. Anulantan. So you may ask your question.
Professor Nalaga, am I audible to you now?
Yes, I can hear you.
Thank you. Thank you after quite some time seeing you, and also a very, very elaborative presentation. Thank you. My first question, I have two questions. The first question is, you seem to have come to a conclusion that ENSO, that is the El Nino and La Nino, and the Indian Ocean Dipole, both are interlinked. But you are also well aware that during the El Nino years, we also may have Indian Ocean Dipole positive or IOD negative, IOD neutral. So how you think that if they are interlinked, we can have the different scenarios? See, when the El Nino is there, then if it is there interlinked, it should be either all the time Indian Ocean IOD positive or IOD negative. But the same year, the El Nino, we have all the three different scenarios. How is it possible, do you think?
Yeah, exactly. That is why I think if you look at these coral records, you can see that different El Nino events have different rainfall intensities, precipitation intensities. I think it is because of the IOD. But the problem is now in the past records, it is very difficult to develop IOD record only with one coral record. Now, we can say that temperature has decreased in our area, but if we want to see whether these IOD events are together with together with El Nino, ENSO events, we have to have coral records from other regions also, especially in the Western and Eastern Indian Ocean. So if we have that kind of coral records, it is possible to identify whether there is any dipole events associated with this El Nino. Otherwise, using only in my record, it is very difficult to say that. So my records can say that ocean temperature has increased and our precipitation has decreased, but it is not sufficient to tell whether there is whether IOD is playing a role. But you can see that when our sediment records, when the IOD is negative, especially for last interglacial, that is the best example, there was a long period of weakened monsoon. That is not just IOD is changing annually. And so, but this IOD change was like couple thousand years. And that was a long period. So during that whole period, monsoon was very, very weak. And so similarly, when the IOD positive for a long period of time, we can see that monsoon was active. But we can tell that because of we reconstructed the temperature records for the whole Indian Ocean. But coral records, the high resolution records we are talking about, that is not sufficient. Our record is not sufficient to tell that, decompose that, because we need more records from the eastern and western sides of the Indian Ocean. So
thank you, Professor. Exactly, that is the answer I also looked for. And also you answered my second question. Anyway, I will go through the second question. But my point is that as most of us thinking, El Nino and the IOD are not directly linked, but they have a link because of the AC interaction, whatever. The second question is actually you already answered, but still I will ask you. See, the worm pool is shrinking or expanding. We would be able to say that then we have to have quite a few core sample in the ocean. Similarly, if you want to know that Indian Ocean dipole, how is positive or negative or the neutral, then we have to have at least core samples each or to quite a few from East Coast and the West Coast. And also in the inland, the monsoons are very, very spatial. Sometimes it may be rain a lot in during a particular monsoon at Ratnapura, but not on the next monsoon. It may not be in the Ratnapura, but in the Nuvarelia. So they are very, very spatial. So I'm not I'm not blaming that the samples are not enough. That is not out of control. It is an external factor. It is, you cannot collect as many samples as you want. And they have a lot of limitation also. But anyway, my point is that to come to this kind of a very concrete, solid conclusion, the samples, maybe these cores in the inland as well as in the Indian Oceans may not be sufficient enough. That was my humble opinion.
Thank you,
Prof.
thank you. Yeah, thank you very much for that. Is a very good point actually. So our precipitation record is based on three sediment cores. For the last 30,000 years, we had one marine core and then another the terrestrial core. Terrestrial core is from the Gavaratan and marine core is of Colombo, and there was another one, Nigambu. And now all three records are nicely correlating. So therefore we can concretely say that because these are three spatially distributed sediment cores, and so we can say that these are we have this short-term variability and the long-term variability also. That's how we came into that conclusion. So in that scientific report article, it is shown all the data, and you can see that. But Ratnapura sediment core is that long sediment core. We don't have anything else. But recently, I collected very long speleothem. So that is like 80 centimeters, and it is high resolution also. I'm going to reconstruct a long monsoon record using that. So then we will be able to correlate that with the Ratnapura sediment core, and it will answer your other part of the question. So whether we can see whether there is same kind of thing. So yeah, thank you very much.
Thank you very much. Thank you. Thank you.
Pradeep and Arul, can I
Sure.
come in for a minute? It's a very interesting discussion and very good presentation. Now, I was thinking that IOD and ENSO are in different frequencies, not the same frequency, no. When they interact, they make a complex situation. That's my understanding. And also, when you talk of monsoon, Sri Lanka is a tiny dot actually. If you think of Indian monsoon and Sri Lanka monsoon, they are not directly correlated because the spatial variation is big there. So my understanding is that I don't know whether you agree or not. Thank you.
Yeah, Professor Matipal, thank you very much. So that is another very good point. So this is the most important thing. Now, when we look at our sediment cores, now our sediment cores are giving us the total precipitation. It is not, we cannot say it is only from the monsoon. And so that is the important point here. So if you look at Ratnapura sediment core, if you look at the marine sediment core, whatever, all the sediment cores are giving us, because our southwest region is receiving rainfall not only from southwest monsoon, and it is from the intermonsoon as well. So therefore, our records are the total precipitation. But when you look at this, the correlation with the insolation patterns, we can decompose that into different components. That's how we recognize that this period has a higher intermonsoon, this period has a higher second intermonsoon, this period has higher first intermonsoon, this period has higher summer monsoon. That is how we decompose that signal into different periods based on the insolation correlation with the insolation curves at different latitudes. So that is how we decompose. Otherwise, but just by looking at that, we cannot do that because it is a combination of all the rainfall mechanisms, because we are getting rainfall from the different mechanisms, not like other countries.
Thank you, Professor Sumadibala. Exactly what you thought is the same view of mine. They are in the different mode, they are in the different frequency. But here in the social media, especially a general perception that all El Nino are going to be dry. But if it is a El Nino and IOD positive, then we normally get more than average rainfall. But unfortunately, if it is El Nino and the negative IOD, we used to get very much lesser than what the rainfall. So I was little frustrated that many of us social media is focusing that only these El Nino decide what happens in the rainfall in Sri Lanka. Thank you, Prof.
Yeah, very, 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 very true. Thank you.
Are there any questions to be clarified? Yes.
Yeah, Professor Nalaka, can you hear me?
Yes, I can hear
Yeah,
you.
I'm Premalal.
Yes.
So is there any reason to select Ratnapur area for the, change in rainfall? The reason is IOD usually contribute to northeast monsoon. Am I correct?
IOD.
IOD is usually, that it will come to the peak during November, December. Right?
Okay. Yeah.
So usually it will, IOD positive, when the IOD is positive, it contributes to northeast monsoon. So why don't you select, that two area, Ratnapura and other, that northeast monsoon area?
Okay, that's a good question. So the problem is we have limitations here. So we have to find good sediment basins. Now we were looking for sediment basins in the northeast region where the to study the northeast monsoon variability, because we in southwest area we have our gem fields, and in the Gavaratan also we had a good sediment core. We could recover good sediment core. They are good sedimentary basins. But in the northeastern side, we don't have that kind of good sedimentary basins. And we drilled many locations, but they were not successful. And actually now we are looking for speleotherms, and we recovered, we could collect about 20 centimeters speleotherm, and we have developed a record for last 2000 years using that, and that is northeast monsoon record. And other than that, we couldn't find any long sedimentary record for the northeastern region. That is a limitation. And we were planning to do drilling in the Trincomalee area, but it was not successful because of these vessel issues. And if we have that kind of sediment core from the coast in the shelf area, we may be able to do that. So, but still, we have some limitations in doing that also. We tried on the shelf, continental shelf. It was not successful. It was sandy, and we couldn't collect long sedimentary records. And so, yeah, so there are that kind of limitations.
Okay, thank you.
Yes.
Good morning. I'm Buddhi Marambi. Thank you very much for
Good
your
morning, sir.
presentation.
Good morning, sir.
I mean, you have to tell me good evening or good night, I must tell you.
Good
Okay,
early morning.
Yeah, this is a comment and a question. I just want a clarification only. IOD is more dynamic when compared with Indian Ocean worm pool. Am I correct?
Yes.
So this dynamic IOD can change the condition of Indian Ocean worm pool.
Yes.
So in that case, what kind of relationship do you expect in the future?
So that is a very good question. So I was looking at now these sedimentary records cannot resolve this short-term IODs. And because the reason is, I can say that as I showed you, the long-term IODs changes, like the last glacial period, last glacial maximum, we can find using sedimentary records, because the sedimentary records resolution is 100-year scale, and we cannot. IOD resolution is like 1 year, 2 year, that kind of resolution. So except without using coral records, using sedimentary records, we cannot do that. So the coral record, again, as Professor Dr. Arul mentioned, so the coral records we have to collect from East and West Indian Ocean to find the IOD variability. Now, worm pool variability, we are talking worm pool variability, not annual variability or decadal variability. It is centennial scale, minimum centennial scale variability. So there may be maybe couple tens of IOD variabilities within our worm pool resolution. So that's the thing. It's a matter of resolution. So I am talking about Indian Ocean worm pool variability in centennial scale, 100-year scale. So within that 100-year, there may be many Indian Ocean dipole variabilities within that. So to understand that, we have to have high resolution coral records. Without that, we cannot go to the past beyond the instrumental record. That is the limitation we have. And actually, Indonesia has corals, and then Mauritius and these islands have corals. And but still, there are no good records like ours to compare with them. So that's the problem with the past IOD story and how it correlates with Indian Ocean worm pool. So.
Yes, madam. You can take a few minutes as we are running out of time.
Very good morning, Professor Nalaka. I am Pedarshani from Nara. This is very informative research, actually. It is very nice to see that you have used foraminiferans to reconstruct the past environment. So you have used a magnesium-calcium ratio for that, right?
Yeah.
So in similar way, can't we use coccolithophore? It is also made up with calcium carbonate.
Yeah.
So same element ratio or different?
Actually, coccoliths are not that used to reconstruct temperatures. I mean, quantitatively. We can tell about qualitatively, but we cannot, people are not using coccoliths to reconstruct quantitatively the temperatures. And many species of the foraminiferas are used, and we can develop temperatures at different levels, and surface level and thermocline and benthic, the bottom level temperatures we can reconstruct. There are equations, but we don't have any developed, as far as I know, there are no any element-based ratio for coccoliths to develop temperature reports.
Okay, thank you.
Thank you, Priyadarshini.
Okay, thank you very much once again, Professor Ranasinghe, for your informative presentation. Now let's move on to our next presenter. Our next speaker is Professor W.A. J.M.D. Costa from University of Peradeniya. The presentation is titled Quantification of the Response of Tropical Rainforest of Sri Lanka to Increased Atmospheric Temperature for Prediction of the Impact of Future Climate Change on their Carbon Balance and Biodiversity. Over to you, sir.
Good morning to everybody. Chairman of the National Science Foundation, Professor Sumati Pala, Chairman of the Climate Change and Natural Disasters Steering Committee, members of the Steering Committee, and members of the audience. Thank you for giving me this opportunity to present the results of our work. As you see, our focus is on the tropical rainforests in Sri Lanka, and we tried to understand how climate change could influence different aspects of the rainforests, focusing on the biodiversity and the carbon balance. We had a multidisciplinary team, Dr. Wahala from Sabaragamu University, Dr. Ukuela from Rajarata University, and also Dr. Vijayatunga from the same university, Dr. Caldera from Colombo University, and our PhD student who graduated towards the end of the project, Dr. Nimalka Sanjeevani. She was from University of Jaffna, currently affiliated to the University of Chile. Then we have another PhD student who is nearing completion, Ms. Madhumali, registered at the Sabaragamu University, and we had technical assistants, Dilum Samarasinghe, Dinet Danushka, and Sunet Kanishka. Our total project duration was 6 years approximately, and we had a total budget of over 18 million. Just to elaborate very briefly on the research problem and objectives, there is no question about the importance of our rainforests, which we have what is left of our rainforests. There is high biodiversity and endemism, and they provide many ecosystem services. And we all know that climate change is something that is happening on much shorter time scales of our actual climatic data record starts from around 1860, 1870. So the trends have been a clear increase in temperature. We cannot say the same about the rainfall. The rainfall pattern has changed, but with a lot of spatial variation across the country. But what we can say definitely is that the rainfall variability has increased. So the rainforest being a perennial ecosystem would be certain to be affected by these changes in climate. We have a database from research on our rainforests from some of the pioneer researchers from our universities. But the available information focuses mainly on the floristics and restoration, not specifically on how the rainforest could be affected by climate change. So that was our focus, to generate that information. But we had to overcome practical difficulties as well. Climate change, as you know, is a long-term process occurring slowly over longer time scales of decades or longer. So that direct measurements of the impacts of climate change would require us to monitor the rainforests, what is happening in rainforests over the same time scale. And no project is going to give us funding for 10 years or more. So we had to take an alternative approach. Since we know that what is changing is temperature and rainfall, the two main climatic variables that change and that influence plants are temperature and rainfall, so that what we could study within a short period of time of about 3 to 6 years would be to see how our rainforests have responded to gradients in temperature, gradients in rainfall, the existing gradients in temperature, and the existing gradients in rainfall. And fortunately, because our rainforests are spread over a wide range of altitudes from nearly the sea level up to the very highest of over 2,000 meters, what we did was we monitored, measured their changes that have occurred over this gradient of altitude, which represents a gradient of temperature and also a gradient of rainfall. So these are the summarized project objectives. We had to look at the different aspects of rainforests, their functioning, their ecology. So we focused on biomass change, and carbon sequestration. And the foliage canopy of the rainfall is basically the heart. Foliage canopy of a rainforest is basically the heart of it, because that is where most of the important physiological processes are taking place. So we had to do in-depth and detailed measurements of how the forest canopy has changed, how it is functioning. And then because we were looking at the biodiversity, we were looking at plant diversity, and we couldn't ignore the animal diversity. So we looked at the diversity of herpetofauna as well. And then we focused, in order to develop ultimately a predictive model, we had to focus on studying the responses to climate, the principal climatic variables, the major physiological processes that drive the growth of a rainforest, the photosynthesis and respiration. So our final ultimate objective by collecting all this different information was to incorporate them into a model which we hopefully would be able to use to predict the impacts of future climate change. This was how the project was organized into different components, and our foundation was we established a series of permanent sampling plots across an altitudinal gradient, and in these sampling plots we made these different measurements. So this indicates where the permanent sampling plots were located. Each was 1 hectare in extent. We had 2 at Kanneliya Forest Reserve, that was at the lowest elevation. Then in Singharaja, Pitadeniya, we had 2. At Enasalvatha, we had 2, that is again part of Singharaja. Then we had 1 at Rilagala, which is close between Navalapitiya and Nuvareliya. Then 1 at Haggala, 1 at Pidurutalagala, and 1 at the highest elevation at Cotton Plains. And this shows the basic climatic gradients across this gradient of permanent sampling plots. You could see from the highest elevation to the lowest elevation, the temperature, there is a clear temperature gradient. And the day-night temperature difference varied in the opposite direction. At the highest altitude, the day-night temperature was higher than at the lower altitudes. Rainfall also followed the gradient for temperature. Highest rainfall at the lowest elevation and the lowest at the higher elevations. Then we also computed a soil water deficit parameter, and we also, looking at the long-term rainfall records, we also identified the number of dry months where we could see that the cumulative soil water deficit increased with increasing altitude, and the number of dry months also increased with increasing altitude. So we did a detailed characterization of the climate. This is only a subset of the data. We also did a detailed characterization of the soil properties as well, because one of the complications that we had to encounter when we establish a series of sampling plots across an altitudinal gradient, okay, we could capture the climatic gradients, but there could be soil variations which could complicate our response patterns. So we did a detailed characterization of the soil in these sampling plots. These are the major soil chemical properties and organic carbon as well, pH and organic carbon. We also characterize the physical properties as well. I am not showing those results here. So by having these gradients in the variation of soil chemical properties and physical properties, We could take these into account when we analyze our data to identify the responses of the climate, so that we could separate out the impact of the soil variation and identify the impact of the climate. Because of the time constraint, I'm only going to give you a subset of the results, some key results from different components that we had in our project. One of our major focuses was on the floristic diversity, community composition, because we were very much interested on endemic flora and also their conservation status. We wanted to see about the endangered species and the vulnerable species. So we focused on the conservation status as well. And during this project, we carried out two detailed vegetation censuses at 2 years apart. So we could establish a very strong biodiversity baseline from the data that we collected for our tropical rainforests across the whole range, we could say across the whole climatic range. So in our 10 hectares of permanent sampling plots, we could identify 276 species belonging to 145 genera and 69 families. And what was striking was that the species were very strongly ecologically specialized. They were present only in a few climatic regions, in only specific environments. So that 85% of these 8,000 tree species occurred in 3 or fewer out of the 10 sampling plots. So this indicates very high niche differentiation, which means that their vulnerability to changes in climate would be very high. Just to show that in a different way, now this shows the number of species that are present at different elevational ranges. Here we have divided into 5 ranges of elevation so that you could see now this number of species, which is a significant portion of the trees, they are present only in one elevation range. These also. So you can see out of the species, more than 50% was present only in one elevation range. And out of the rest of it, a majority was present only in 2 elevation ranges. There were only a few which spanned 3 ranges of elevation. We looked at the diversity, how it varied with altitude. Very clearly, the tree diversity decreased with increasing altitude. The same trend with species richness. But we could also identify the mid-elevation range from 1000 to 1200, which is the lower montane zone, which acted as an important transition zone where we could find some species which were occurring at the lower elevations and also some species which were occurring at the higher elevations. Endemism, the percentage of endemic species declined with increasing altitude. But when we looked at the conservation status, the conservation vulnerability also changed along the gradient. We categorized the species into endangered and above, vulnerable, and LC means least concerned and NT is not threatened. So that you can see the percentage of species that are classified as endangered or higher increased with increasing elevation. On the other hand, the percentage of species which are classified as vulnerable increased were higher at lower altitudes, which means that the conservation importance is higher at both higher and lower altitudes, by implication at the mid altitudes as well. Now in this analysis, we considered all the factors, the climate, soil, and other factors. And from this diagram, what we can conclude is that climate exerts a major control on the forest structure and biodiversity, where we could identify lower temperatures, greater day-night temperature variation, increasing soil water deficit, and atmospheric drought, that means higher vapor pressure deficit, reduced tree growth, diversity, and species richness. On the other hand, greater rainfall and greater radiation intensity had the opposite effect, had positive effects on these parameters. This is the same slide, sorry. The variation in biomass. The variation in biomass as well as the biomass increment showed a clear mid-elevation maximum. It was maximum at mid-elevation. Then during this study, we developed improved allometric equations to estimate biomass. The normal allometric equations to estimate biomass use only the DBH, diameter at breast height, and the wood-specific gravity, and wood-specific gravity is usually taken from global databases. In this project, we developed relationships between DBH and height so that we could also incorporate tree height into the allometric equation. And more importantly, we developed a database of wood-specific gravity of our own tree species. So when we incorporate those species-specific and locally measured wood-specific gravity, and also when we incorporated tree height, we could see that we could improve the estimation of biomass by a significant margin, which means the biomass estimation leads to the estimation. It is the foundation of the estimation of carbon sequestration. So we could improve the accuracy of the carbon sequestration estimates. And we developed detailed diagrams of the forest structure. These are the two extremes, the lowest altitude and the highest altitude. And we could see clear changes in the forest structure and also in the dominant species. So we have a detailed characterization of how the species composition changes across these environmental gradients. These are some of our research assistants at work in different permanent sampling plots. And we actually established automated weather stations at all of our elevations. Now I focus on the canopy. As I said, the foliage canopy is the heart of the functioning forest, so that we wanted to quantify how the size of the canopy, which is measured by the leaf area index, and also the structure. There are many structural properties which we collectively call as canopy architecture. And that has a very clear and significant influence on the photosynthetic rate at the canopy level and then at the biomass production and growth rates. So we looked at the foliage canopy. We did detailed measurements over 8 rounds over a period of 2 years using hemispherical photography, which is a technique which allows detailed characterization of complex plant canopies. This is a summary of our results over the 8 rounds, how the canopy size or the leaf area index has changed with altitude. You could see very clearly the size of the canopy decreases with increasing altitude. Over the period of time, what has happened to the leaf area index, the size of the foliage canopy, it varied in the different plots, but the majority of plots had shown an increasing trend in the canopy size. All this have to be taken into account in developing a model. And then we also characterized the influence of different environmental factors. We could see very clear relationships with all environmental factors, how they control the leaf growth, leaf expansion, and the size of the foliage canopy. And then we developed several multiple regression models which would allow us to predict the size of the canopy using the key climatic variables. We also did a detailed characterization of the canopy itself. We looked at how the leaf area is distributed within the canopy, and we could find an interesting result. These diagrams might not mean much to you, but what they show is that these are diagrams of the canopy openness, how it varies in different directions. What it shows you is that these darker colored areas are the areas where the canopy is thicker. Lighter colored areas are the areas where the canopy is open. So for example, on okay. Right. Here. Okay. What you see on that extreme right is the canopy at the cotton plains. And there you can see the canopy is quite open. What you see on this side are the canopies at Singharaja, which are much less open. What we could see is that the concentration of leaf area, more leaf area is allocated to directions where the solar radiation is greater. So that was what we saw in this study. And then we looked at the remote sensing photographs, remotely sensed photographs, and calculated for each of these canopies over a period of time, this commonly calculated measure of the canopy, NDVI, and we could see a clear decline in NDVI, the maximum and the minimum, but no clear relation, maximum and the mean, but no clear relationship with the minimum. And then we could identify the environmental controls of the NDVI as well. Clear relationships with all environmental parameters. And then we developed, again, predictive equations using multiple regression, equations to predict NDVI using the environmental parameters, so that once NDVI is predicted, we can use, then we developed relationships between NDVI and leaf area index so that we could use that, we can go back in time, get the satellite data, get the NDVI, and estimate the canopy size over a period of time. So these were the relationships that we developed between leaf area index and NDVI. Coming on to the herpetofaunal diversity, these are the families that we observed, and the numbers of species that were observed from different families at different altitudes. The elevation pattern was that species richness showed a mid-elevation maximum. Diversity of herpetofauna also showed a mid-elevation maximum. But interestingly, the percentage of threatened species increased with increasing altitude. This is the variation of environmental factors that influence the herpetofaunal diversity. For example, we looked at the relative humidity, the temperature at the ground level, the canopy cover, and those other parameters, and there were clear relationships with altitude on these environmental parameters influencing the herpetofaunal diversity. And based on that, we could clearly separate out the herpetofaunal diversity based on the altitude, and we could also identify the environmental controls. Then another aspect of our project was to look at, once again, focusing on the productivity photosynthesis process. The stomata are key organs in the foliage canopy. They are responsible for absorbing carbon dioxide for photosynthesis, and also they control the loss of water from the canopy through the process of transpiration. So we had two detailed studies on stomatal anatomy. I'm presenting the results of only one study, which covered 19 species belonging to these three families. These three families were present across a wide range of altitudes, because we had to select these because, as I told you earlier, species as well as their families were very much specialized in their environment in which they were present. These are some of the stomatal micrographs that we developed, one from Carnelia and another from Singharaja. Each panel has 6 species, even though you cannot make out the names of the species. The variation of the key stomatal anatomical parameters, stomatal density, stomatal index, guard cell length, and the potential conductance index. This is the variation at the family level. This is the variation at the individual tree species level or stomatal density. And based on the stomatal parameters, we could classify the species into these clusters. And in the second study, we did a further 20 species. So we have a fairly comprehensive database on the characterization of stomata of a wide range of species in our tropical rainforests. Finally, to come to photosynthesis and respiration, in photosynthesis and respiration, we measured how the rate of photosynthesis responds to the variation of light intensity, which is important when we ultimately incorporate these information into a model. And we did light response curve for 79 tree species, to my knowledge. You don't find this much detailed information in the literature anywhere for tropical rainforests. Then we also characterized the response to carbon dioxide for 25 tree species. And these tree species represented the different vertical strata of the forest canopy, because ultimately when we developed the model, we had to stratify the canopy. We cannot use it, we cannot consider the forest canopy as one uniform unit. So we stratified it into these three strata: canopy, subcanopy, and understory. And we did measurements on a few liana species as well. And these species came from different altitudes, so represented lowland forests, submontane forests, and montane forests. So we developed a very representative and comprehensive data set for photosynthesis and respiration. I'm just going to show you one. Now in the light response curve, we can estimate 5 parameters for the light response curve. This is one important one, the maximum photosynthetic rate when the plants receive saturating light, what we call Pmax. This is how it varies for the three canopy species representing the three canopy strata. So you can see that there is significant species to species variation, which we have to capture when we develop a model. This is the same for the respiration rate. And I'm not going to show the other results of the CO2 response curve. Those parameters also show the same species to species variation. So our ultimate aim of this project was, one final aim was to develop a simulation model to predict the impacts of climate change on tropical rainforests. And this work is not complete, it's still going on. But we have collected most of the information and developed most of the relationships that are required in the model, but there are gaps as well. This is the basic flow diagram of the model. It has a canopy photosynthesis model from which radiation use efficiency is calculated. And then from our hemispherical photography data, we calculate the radiation interception. And combining radiation interception with radiation use efficiency, we calculate the biomass carbon sequestration rate as net primary productivity. And then taking out respiration, we calculate the annual carbon sequestration rate. This is our canopy photosynthesis model, where we stratify the canopy, incorporate response functions for each stratum, and then compute the canopy photosynthesis. So we have collected almost all the information, all the response functions for this, but there are certain things that we need to resolve. For example, what is the diurnal variation of incoming radiation, and how the leaf area index, the total leaf area index that we have measured through hemispherical photography, how it is partitioned between these three layers. So those are things that we need to work on. Coming to section 3, the research outputs, capacity building publications. Already Dr. Nimalka got her PhD in 2023. And Ms. Madhumali has completed about 80% of her PhD thesis, and she is expected to submit it in December 2026. We had these publications in Katina Nature Scientific Reports, and also Tropical Agricultural Research. Altogether 6 publications in Geomatica and Acta Ecologica. And we had 1 preprint as well. There are many manuscripts. Some got rejected, so we have to try again, and some in preparation. Research outcomes in terms of real-world applications, policy or industry impact, and academic contributions. Real-world applications, we believe that the information that we have generated, the location and species-specific information on the flora and herpetofauna are very useful, will be useful in planning and implementing conservation and restoration efforts. Our improved allometric equations will be useful for more accurate estimations of forest biomass and carbon sequestration estimations. The information that we have collected about species level, photosynthetic light and CO2 response parameters, we will be using it to parameterize our simulation model to estimate the future impacts of climate change. And the species-specific information that we have generated would be useful in matching tree species with appropriate sites when we try to support forest recovery and regeneration and restoration. Direct and indirect contributions to the national economy. As I have already said, this information can be used to conserve this ecosystem as an ecosystem at the ecosystem level, because we believe that this ecosystem plays an important role in water security and also in tourism and leisure. In addition to conservation efforts at the ecosystem level, the conservation efforts at the individual flora and fauna level, particularly those that are vulnerable and endangered, information would be useful so that we can contribute to more efficient forest restoration and reforestation, and thereby reduce the costs and losses from forest degradation and climate vulnerability. And we have developed important research capacity, data sets, and long-term forest monitoring resources. Particularly, we have established these permanent sampling plots and automated weather stations. So next steps, of course, I will be continuing the work with the model development until its conclusion. Actually, my workload during the past year, because of the additional responsibilities that I have at another research institute, prevented me from completing that section, but I will be continuing that. What is more important is that we need to develop a mechanism to continue these permanent sampling plots and also the automated weather stations. And I will be retiring from the university service end of this year. So I hope that somebody else will take it up, or we could develop a mechanism. I believe that we can interest the corporate sector in their social responsibility programs to support such an initiative through the NSF. So with that, thank you so much. And once again, big thanks for the National Science Foundation, Professor Sumatipala, and the steering committee for providing the funding. And I would like to particularly mention these individuals who work very closely with me, Dr. Geetika Ayappa at the early stages, and then Ms. Dilani Jayavira, Engineer Mahesh Disanayaka, Engineer Sureshini Varnasurya, and Madara Veerasurya Gedara also worked closely with me for a significant period of time. And I have already thanked the members of the steering committee, and I also have to thank the technical staff of the university and the finance branch of our university. Thank you so much.
Thank you very much, Professor Di Costa. Now the floor is open for discussion. We have 15 minutes of time for the Q&A session.
You, Professor Costa, for actually, it's very elaborative work and your wonderful presentation of what you have done. And I have, actually, I enjoyed it, you know, it remembered me a lot of different technical reasons, details, so on that I had learned throughout my life. But I have a general question to ask. Now, as a a senior researcher, how do you believe that this type of important information that you collected through very meticulous ways and using the state-of-art methods can be communicated or disseminated with the general public in that case? Because maybe not school students and then the general public. So how do you plan to do so?
Yeah, thank you. Thank you, Dr. Parakrama. Yeah, that is a fundamental question that all researchers, publicly funded researchers have to answer. I don't have a satisfactory answer to you. Now I'm at the end of my career and I have to admit that I have not done that successfully. I have tried to do that, but I have not done that successfully. That is because the science, the technical level science that we do at the research level, how we communicate to the general public, their understanding is diverse and their awareness is diverse and their needs are also diverse. So that ultimately in a project like this, what we would want to happen is that now these very sensitive ecosystems are shrinking with time. Deforestation is happening. Now at the moment I am in the tea sector. Now one of the major reasons for the reduction of the tropical rainforests is the tea cultivation. Even now when the tea prices are good, for economic reasons, people clear the forest boundaries and establish tea. That's for an economic reason. And it's very difficult to stop that. The only way to stop that is to make the public aware. But when the awareness, how do we compete with awareness and economic needs? I think that is a question that all ecologists, all conservationists have continuously tackled. And I don't think we have found the right balance. For example, now during the period of this project, initially to our Singharaja Pitadeniya project, we had to access that through Lankagama, and there was no road access. We had to go there we had to travel by foot about 4 to 5 kilometers with all our luggage, gear and everything. But then in the middle of the project, a road was constructed. Now the people are very happy and I think when we are in the cities, we take all these things for granted. Now for them, it's a big thing. But then the road was constructed in the middle of the forest. So that is the conflict that we have. I think we need to continue these programs of awareness. Communicating, I think science communication has to be done in simple language. And we do that at school, but we lose it at some point when somebody goes out of school, goes into employment, the values change. So it's a fundamental question, and I think all of us need to address that to the best way we can. We should find better ways of communicating the results of our research.
Yeah, Professor Kata, thank you very much. I think what you presented has lots of scientific merit, which was proven. And I sincerely hope you can continue and complete the modeling part, which is going to be extremely useful at the end. I just have one question and two quick comments. Can you go back to your first or second slide that you showed that with elevation, the temperature, that there was a nice table with I'm sorry, I'm sorry that
Oh, no problem.
I'm taking a lot of time here of yours. That was stable.
Yeah.
Yeah. This interesting but clear kind of a picture, but I was very interested to look at the DTR, the diurnal temperature range, Professor Costa. How it goes is up to certain elevation it increases, beyond which it decreases. So I just wanted to know from you whether it's due to increase in nighttime temperature, diurnal temperature range can change because of that, or due to any other reason.
In a separate study, I have analyzed this. It's different in different locations. If I remember right, at higher elevations, the nighttime temperature increases, but the daytime temperature increases by a bigger margin. And at the lower elevations, of course, it's clear increase in the nighttime temperature. Yeah.
Right. Some of the results that have been published and what you have seen in the recent past, in the cooler climates, the night temperature increases at a faster rate than the day temperature. That can bring down this gap. So that may be a case. I just want to know. And the two comments that I'm going to make is that, you know that very recently the government has approved the establishment of something called Almighty Upper Watershed Management Authority, which can use the outcome of the work, provided the modeling work also works out well. The second point is that the net zero 2050 for Sri Lanka is being revisited right now due to various reasons, I must tell you. And the outcome of your work would be very valid to set the baselines. Always the problem is the baseline, right? When you have such meticulously collected information and analysis, that would help. So I don't know whether all published information can go in. I see that a lot of other work also to be done and published. I'm not trying to ask for or requesting you to give that information. But once it published, it's important that it goes into a document like that, which will stay long and will be built upon later. So those are the two comments that I want to make. If you can capitalize on that, that would be very useful. Thank you.
Yeah, yeah, just a quick reply on that. Yes, all this is publicly funded research. So the results should also be available for all the policy decisions. So whenever they are required, of course, we would prefer to publish them first and then share. But even before publication, if it is required for a national initiative, I would be very happy to share those. Yeah.
Just a quick comment, Professor Costa, and you know there are all workshops after workshops to get this information, and I don't think you can attend all those workshops also. So if you can give us a name, for example, to be contacted and invited to those workshops, that will be a very useful thing.
Okay.
Because continuous contact is going to be helpful in these cases. Thank you.
Yeah. Yeah, I will. Yeah.
Professor Costa, can I come in and ask one question? Or
Yes,
comment?
Professor Sumatipala, yes, certainly.
Yeah. Now, I was just thinking of the, recommendations that we can take from this to the policymakers. Now, your finding is that, mid elevation, the biomass is maximum. You said something to that effect, right?
Yes.
Mid elevation, the
Yes.
biomass.
Yeah.
Yeah. So that means the carbon sequestration also will be maximum in that area, right?
Yes.
Yeah. So now I'm thinking maybe for plantation, for Sri Lanka to go on plantation sector, maybe the forest department can be given this, idea that there may be for timber or any other process. So should we not, give them the idea that the best areas to plantation would be any type of plantation would be mid elevation than the high elevation. Of course, high elevation is for something else. But I'm thinking of, if you're thinking of biomass and tackling the carbon, the climate change, increased biomass sequestration, taking all that in the mid elevation would be a better area to do the forest plantation and maybe timber harvesting. Wasn't that be the case, Professor Costa?
Yes, that could be a logical conclusion from these findings. It has a physiological basis also. The balance between photosynthesis and respiration is maximum in the mid elevations. From a carbon sequestration point of view, I think it would be a good idea to recommend plantations, forest plantations in the mid elevations. And from another point of view also, to my knowledge, we have a significant amount of degraded lands, lands that are already, the soil is degraded, so that which might not be suitable for any form of agriculture. So from that point of view also, mid elevation could be recommended for plantations. But having said that, the upper elevations are also okay if land could be found. Now, in a separate study, I have calculated the biomass of all our plantation forests. There, the highest biomass is found at the higher elevations, but that depends on the species and the area as well. But as a general recommendation, yes, I agree with you.
Okay, thank you, Professor.
Yes, Ms. Nimalka Kankamge, you may ask your question.
It's not the question. I would like to add something what Professor Costa saying for the replying to the Professor Sumatipala's answer, because I was thinking that we have done that research in the natural forest, in the forest reserve. So basically we calculated the above ground biomass and carbon sequestration for the native plants endemic, which is in the forest. So if we are doing for the plantations, as Professor Sumatipala suggested, I think they're looking for the fast growing plants. Also, we can suggest in the mid elevation, that is very nice. But in this research, basically we focus on the carbon absorption for the native forest. I think for the carbon absorption, this is very best place at the mid elevation.
Thank you, Nimalka.
Thank you once again, Professor De Costa. It's now my pleasure to invite Professor Indrika Rajapaksha from University of Moratual to present her research titled Heat Stress, Quality of Life and Well-being of Elders Living in the Tropics, an experimental investigation on aging in place in a low-income settlement in Colombo metropolitan region. Over to you.
Good afternoon to everybody.
Yes. I'm here to present our project on heat stress, quality of life, and well-being of elderly people living in tropics. And this study, because at the time of awarding the grant, this is supposed to look at two districts, areas in wet and dry seasons. But unfortunately, because of the limitations of funding and unforeseen conditions of the pandemic outbreak, this was limited only to Colombo with justifications. So I'll explain why Colombo is. And it is a microclimatic study where all climatic information will go for weather data at the macro level, but the microclimate is what is immediately we human beings are experiencing. So this is an experimental investigation on aging in place. What is aging in place is people prefer to age the places where they stayed for a longer period. So this is very common in low-income settlements compared to middle-income and high-income due to migration of children. They will put into elders' homes. But these low-income people, they are predominantly aging in their own house. So that's why we have selected, and also this goes for the Sustainable Development Goals target, where we should not leave anyone behind. So this is the most vulnerable group, which is affected by this climate change impact. So this study was started by connecting the multidisciplinary. I'm from the field of architecture, specialized in the architectural sciences, and with the specialties of medicine, demography, statistics, and public health. But unfortunately, with the limitations, I got the expertise of the team, but later this was more focused towards the engineering part of it, where I got one of the pioneering, the person, researcher from Tokyo University working on this, because we had the intention of developing the national thermal comfort standards, but this didn't go up to the national level due to these limitations. And this is a budget of 2.5 million, it is only 25% of the grant was received, and approximately 3 years. Right, so let me start talking about why this study was started. Because we know the synchronized global trends. It is the climate emergency and demographic shift of the population aging. Aging in Asia is very rapid. 55%, 6 world's elderly population lives in this region, and which could be considered as the oldest people living by 2050. Region is heating up faster, and the growing season length with more hot days and warm nights. Older adults, as we all know, are susceptible to the health impacts of rising temperatures. Temperature extremes, they exacerbate the heat-related morbidity and mortality. And as we all know, it's said that more than 90% of time, these elders and children spend indoors. Among them, 72% of time they are spent in residential settings, and 80% of their day spent in engaging sedentary activities. They are not active. They are just seated or moving just a small distance. So sedentary activities with global these warming trends and also residential settings is the priority of this study. When it comes, we all know, we all have seen, now again, this is a prominent social media thing that about giving us warnings. So it comes in nice graphics, but we have never experienced, or this has not made the people understand easily. So what they says is, go indoors and keep cool. What has happened to this? So indoors, this is what the research has proved. high heat stress days and nights are increasing in tropics. We all are living in overheated buildings. If the air condition is not, sometimes the air condition is also not supporting. So it is overheated building is a common term. It's not just a building, it's an overheated building. The growing dilemma of indoor heating is a complex and increasingly important challenge. So when we talk about global warming, we always missed and we are not connecting the places we live, the places we work. So, but we associate 90% of our time staying inside buildings. So it's very important. So as the premise to this research, what we have looked at is a significant gap understanding of older people's thermal experience in naturally ventilated indoors, because these vulnerable people, communities, they cannot afford an air condition. And even affording an air condition is another vicious cycle which increase the global greenhouse gases. So there need to be a limitation of using of air condition, but with the warming trends, we cannot depend only with this natural ventilation. So therefore, on the developing Asian nation in Global South research is very limited, and this is going to be one of the pioneering study looking at these vulnerable communities in Sri Lanka. And we can see the IPCC diagrams. A child born in 2020 is living in an environment for 70 years if he lives more than 35 to 36 degrees. And also at the other side, the right side, it is earlier we had the pyramidal shape population graph. Now it is bulging, where we get more and more aged people into the society. So the research question came, how do the global warming trends challenge the livability of vulnerable communities? And then this position on SDG 11 and SDG 3, and where we will investigate the microclimate of aging in place to assess the prevalence of indoor heat stress and quality of life of these elders. So in the study, we have developed the objectives is to develop elderly population dispersion maps, then the hottest locations with highest national elderly populations, to develop the house form typologies of aging in place, to experimentally investigate the endothermal environments. And also, Sri Lanka is lacking our thermal comfort standard. It depends on our acclimatization, body physiology. We still use the international standards. So we had the intention of developing our neutral temperature standards, but this study limited to look at it only for the people who are living in Colombo, only a sample of 150 elders. And the mean skin temperature profiles were developed, and also we evaluated the quality of life, young elders index, which is validated for Sri Lanka, and also to look at the cooling poverty and energy poverty prevalence. Okay. It's not moving. Thank you. Right. To start up with, what we did was, we started, as I said, we did these elderly population dispersion profiles for 4 districts as it was started. By after that, we revised the project for the 13 districts in Colombo, and also we have looked at the land surface temperature profiles, and we can see it is more towards the Colombo, and the northern part of Colombo is the hottest location, and the population-wise also, we have selected the the DS division based on this population profile as well as the LSD profile. So similarly, we have developed, as we had the intention to do pick the critical areas of the Ratnapura district, Trincomalee and Anuradhapura, to cover up the wet and dry zones. But unfortunately, we couldn't go ahead. But this work has been completed. So I'm not going into detail discussing about this information. So going into the details, there are 13 district secretary divisions in Colombo and also 35 GN divisions. 35 GN divisions, of which we have taken the surface, the area temperatures, and we have decided to take Colombo. And because of the number of population is also elderly population, according to statistics, is very high, as well as the temperatures are also high. To confirm that, we have done the GIS maps of Colombo to identify the critical location. And then we did the NGBI, LST, and UTFBI maps. And then we realized Matapulia is the location for the highest temperature in Colombo, as well as which represent the highest number of elders. So that justifies the critical case of our study. To get into the methodology, so what we did was we have selected the site based on our justification on the population and the temperature conditions. We took the ethical clearance, and then we did an on-site investigation to get the subjective and objective measurements, as well as we did a thermal comfort analysis using the FLIR tool and the CBE that is developed by University of California, the thermal comfort tool, where we have developed the neutral temperatures for Sri Lanka as one of the pioneering studies. But this sample is not enough. This will go as our future work. So this is how the study was done. It was a very difficult study because the public, the people were not aware of research. So we went to the houses, we took 2-3 weeks to make them understand, to become friendly with them and to talk to them. They thought we are giving some incentives. I'm coming from a government agency, giving them some gifts or something like that. And when we selected the houses, it was a huge fight among the community. Why you have selected this house? You have not selected that house. They were thinking I'm coming an agent of the government, giving some funds or incentives. So even the police came to the site, huge battle between people. So this is going up to the people's living real places, not collecting data from any websites or databases. So this is the original data set which we have. I think it's a valuable data set. So we have, you can see the conditions of these houses and the people, and majority, there are several differently able people. They don't come out. They can't come out. Another huge issue of Sri Lanka, we think we do not have this differently able people, but we have a lot inside. So, and then we went to them, and it was really a happy moment to them as well. They wanted to talk to people, but I found the community is living happily. They have a lot of relationships and connections. So, and the community helped us to get, and so we have selected, according to the sample, the number of elders, we selected 150 houses. We did the pilot investigation with 100 houses. Then after that, only we developed the questionnaire for the ethical approval. And then we conducted the on-site investigation of 150 houses. Yes, so I'll go all information in details given in the final report. So here I have, what is the message I'm giving is, the indoor temperatures are close to 34 degrees. But WHO says a healthy home is 24 or below. So this is the question which I have to tell. And this is not only because we think that they are vulnerable houses, but even if you go and measure an office, it is the same. We don't feel it because we get this mechanical equipment. Again, we support. We help the greenhouse gas emissions and global warming. That should be stopped. So in this, although WHO recommends 24 and 60% humidity, we are beyond the healthy home guideline. So why I'm telling that we cannot take this because WHO has not, they have taken maybe the most privileged countries, developed countries. So this is a developing country as well as our body physiology is supporting the acclimatization because we have lived for a longer period in a hot country. So we could go up, but we have not. We still, even for air conditioning set points, we still use the international standards, which is wrong. So, and then from this study, we realized our people with their adaptive behaviors. When we get hot, people could go to a window and open a window. But when it is air conditioned, it's closed. So people can try some sort of using a fan or a paper or something to blow some wind. Those are called the adaptive behavior. But our buildings, which we have, is when it's air conditioned because the adaptive behaviors are very high in naturally ventilated buildings because they are active occupants. They go to some place, they look out, they open a window, or they can raise a blind to see outside, but the passive occupants are very high in air-conditioned buildings. We don't do any actions. We just sit down and get cooled ourselves. And it is also not be a situation reality when the warming goes up. So, so now you can see the most of the heat comes from the roof. So these are thermal images of the buildings, the roofing. We have several of that collected in our database. So the roofs are mainly asbestos, tin roofs, and cement block walls are again 34.8. These are some of the things. We have not gone into detail into this analysis since we were in the study primarily focusing on the comfort. But each country has their own temperature, the thermal comfort standards. So I have put only few countries, but there are a lot. Sri Lanka is lacking. At the same time, what we did was we have taken the thermal skin profiles images to find out the skin temperatures of these people. And we found the head part is most heated. And now we are developing a model using these images. And mainly our people, the temperature, the mean temperature, skin temperature is higher compared to the healthy person's temperature, which is 34 maximum, but we'll go up to 35.7. And now in future, that imagine some of the houses we recently done, the temperatures has gone up to 37, which is now getting closer to our body temperature of 38 degrees. So natural cooling mechanism of our bodies will be controlled indoors, not outdoors. Outdoors, we know we can go and stand even under a tree. But indoors, there is no escape. Even the air conditions are not efficient enough to cool. So later, what we did was we have taken the quality of life index for young elders, that is 60 to 74. This is a validated questionnaire by the medical faculty. So we have checked their physical, functional, mental, environment, spiritual, and the social domains of these people. And then this is, again, we have collected all the details are given in the report. So of that, we have found that our overall mean, the mean value of this quality of life index is 45, which is below 50. So it is more, we are into a very low level of quality of life. Among them, the social and the functional aspects has go above 50. So the environment aspect is very low. The social aspects are good, and also the functional domains have scored. But in total, when you go to the overall mean, it is low. And also, we have collected all electricity data. It was very, very difficult to get those things. Because they didn't want, somehow we managed. So we have found that these people are into a energy poverty condition because they spend 10% of their income for this electricity. So most of the developed countries, it is below. So with the latest electricity, I think the unit cost, we have to think of it, and majority controls, maybe they all have fridges, all these required things. They control the use of fan. So cooling is not their priority. So they live in a very hot interior, but they do not want to switch on a fan because of their financial constraints. And also they have experienced a lot of electricity disconnect situations because of the delayed payments. So this is another area, the social justice of climate change or global warming is there in this community. So we have to overpower. I think we have to support the social justice part of the communities. Yes, so the results, and also you can see with the temperature, the mean skin temperature increasing, it decreases the quality of life. So this is the score we developed. And then when getting into the all the in detail analysis, how the energy poverty, the cooling poverty has been calculated, everything is presented in the final report. So I will not explain those things here. Yes. So when coming into this is just close to 2.5 years with some limitations. So we managed to publish the Elsevier publication because in architecture field, we have only very limited number of journals. So we could manage to publish this paper. And then we had the IEEE conferences, these are index conferences, and most of the 2 papers have got the best paper awards as well. And this is a continuing study area. We have not ended up, and the research assistant did the master's by research 1 year, and now he's doing his PhD in University of Columbia. And the other one again started and doing the PhD in RMIT, where in Morocco we have this master's by research 1 year, where we support the good students to get their publications to lead their PhDs. So through this project, that's the capacity building which was done to help these students. And also we did publications as abstracts in international symposiums, and also the workshop into the Colombo Medical Faculty. So that is not the end. So we have all the data, majority of data is still remaining for analysis. But this study has proved that the indoor overheating is prevalent. People are living in heat stress interiors, and their quality of life is very low. And this is the most vulnerable community of Sri Lanka, aging, the elders, as well as living in vulnerable communities. So this has gone into the most vulnerable community of the country. Yes, when getting into the direct contribution, so this will lead towards the public health cost reduction and disease prevention, and also ask for the energy efficiency and reduction of cooling, the energy poverty. Because when we talk about poverty, I do not think everyone has thought of that we are having this cooling poverty and energy poverty situation. I have never seen any analysis on poverty. This is the poverty. It is emerging with the global warming, the heat stress situation. So nothing, not in a single policy in this country. And this will also support enhanced housing and national housing policies, and also strengthen the climate resilience through house design innovations. We need the innovations. So direct contributions to social equity and poverty alleviation. long-term and economic productivity, innovation and technological development in design practices, policy development and global collaboration, sustainability of energy and climate policies. Energy and climate policies need to be combined. So I think we need housing, energy, climate, all connected policies to address the present situations. So therefore, we recommend enhance endothermal comfort through climate responsive housing designs. We do not have this kind of designs in Sri Lanka, very limited. And although the bioclimatic designing, when we look at a building, I think the public should aware it is not just walls and floors and roofs. There are a lot in terms of the space you live, it is the interior. So we are not aware to understand it. So it is not the proper building for future which we are living. So it needs to go towards a lot of innovations in terms of design, and we need to address energy and cooling poverty. Cooling poverty index need to align with the electricity tariffs with vulnerable levels. So national energy security for that, and passive cooling, and also promote heat mitigation, education, and community-based interventions. Also, we need to improve health resilience of the urban aging population and integrate the data-driven policy making. So the data-driven policy making is essential to support these interventions. Yes, so when coming to the ongoing process, because we have started with a very sort of a comprehensive project, we couldn't do it with these limitations. It was awarded in 2017, but the money came 2 years later, and it was reduced a lot. So, but our interest towards taking this towards the national level has never stopped. So we have now started the same neighborhood analysis. We developed several, we have found close to 7 to 8 types of vulnerable houses. Now we are developing a design guide where we could distribute to national housing, or anyone who is interested, please use this at least as guidelines when you want to live in a place which will not burn you inside, because the strokes and everything would start with this temperature condition window. And then these are all empirical thermal monitoring. We did the monitoring, as well as we have started the simulations to develop it. So this is ongoing work, as well as this is the actual house in a settlement in PETA, where we are now going to retrofit it to bring down the 38 degrees temperature towards the acceptable level of 20. That is our indication. So we are not looking at a house from walls and how it looks at, but we have our baseline. It is the indoor temperature at the comfort level. So if it is 27 years per person could live healthy living. So these are going at healthy houses, where this is a renovation which we have started in PETA, a real house. As well as I would like to bring this situation now, the National Housing Program is talking about putting up the same building block. Same building block planted. It is mass construction. And we have identified the typologies, it's C-type, H-type, and I-type. So that I's and H's and C's combined together and put people inside, massive number of people, houses. So this is another study which we are now working on. It's ready for publication now. 1,137 houses in that. So that is another area where we are again looking at the plan. It's raw. The forms and the interiors are very hot. So these are hot ovens, asking people to stay. So it is wrong. So these are some of the images which we took in some of the buildings. The building envelopes are heated to 58 degrees, and the people are again heated up. This is the silent part, making invisible visible is my thing. So this is the silent part of buildings. We don't see this. We see only nice plans, nice pictures of the houses. All are nice pictures, but this is the performance of the building. How it performs when the heat comes. This is the global warming which we cannot stop. It's 38. It started in 1960s, going up and up. Never reverse. So making invisible visible, where only the equipment can see. Unfortunately, I didn't get this equipment from the NSF grant. This is the equipment supported by the University of Moratuwa grant because I was asking several equipment, not a single equipment I got from the grant. So therefore, but I managed because of my passion to get into, and this is the area which has not been touched by any of the research. Architecture field, the research is very low. So, and also I'm going up to the level of the person, the where you live, it is very important. So then again, we found these people are hot and living in hot, and we need to stop this. We are spending billions and billions putting up another set of hot tower. So what will it impact? People will die. And also, we do not have any data on how many people died because of heat strokes. We don't have. Even you go and ask from the hospital, we don't know a mechanism. I asked from Professor Saroj. Then he said there is no problem. So heat strokes, it's not outside. This will happen very soon inside. Sudden deaths. And this will have an impact on national health budget. Definitely this is having an impact on national health budget. So it is very important that we should not put the same problem-giving model to put people in 2026 onwards where the temperature is ever increasing, not decreasing. Right, so at this moment, I would like to thank National Science Foundation for giving me this opportunity to present our research as well as funding this research, and also the officials who worked with me very closely and supported me. So I think behalf of the team, I would like to thank Engineer Mahesh here and then Engineer Sureshni, as well as earlier Ms. Dilani. I think you are heard in my I think, yeah, sorry. And Lani as well. So, as well as I would like to thank the Into-Environment Diagnostic Lab, which I have set at the Department of Architecture, University of Moratuwa. So, I managed to do these projects with the National Research Council grant and the Moratuwa grant, which gave me this equipment to go ahead with the project, and also the Glaman Niradhari and communities in this and actually community. So we are exploring opportunities for any gap filling, or because these are important areas to be looked at, if possible. Anyway, the studies are going on, but we will try future grants to take up this research forward. Thank you.
Very much, Professor Rajpaksha. Now it's time for the discussion session. Yes, sir.
Thank you, Professor Rajpaksha. I'm Buddhima Arambe from University of Paradene. In the penultimate slide, the statements that you made are pretty strong. I must tell you, conclusive, everyone should think of it seriously. When I look at all climate conventions in the world, if you look at them very carefully, everything boils down to human health. So they are actually human health conventions. So I'm really glad that NSF was able to fund this. at least at the initial stage, and you have continued with it. And really nice to see this type of information is surfacing from a scientifically valid result, although your sample size is small due to obvious reasons. That's my comment. And I sincerely hope you can continue. My question was not related to your research. At the very beginning, you said only 25% of the funds were received. That gives two connotations. One thing, you have asked for only 25%. The second one, you have asked for more, NSF has not given. Which one is correct?
Thank you for the questions. Yes, first of all, thank you for appreciating the research, and we'll continue with great passion. Regarding the funds, we asked, only 25% received. So that's why the study got limited. And also to look at it in fair way, at that time, the pandemic outbreak was there to 2019. The grant, I got the money in 2019, but the research was awarded in 2017. The situations got changed. So then, and requested actually air quality monitoring as well, connecting with this, where there was a comment from the panel to look at 2 districts in wet and 2 districts in dry zone. Unfortunately, they couldn't done because of the funds availability. Only the transport supports Colombo. So therefore, we couldn't go ahead with other districts. And not a single equipment was purchased from this grant. So fortunately, I had even I didn't have fortunately I had the equipment, but I wanted to go for a thermal comfort, so special monitor. Now the problem in my publications is we have done the mean radiant temperature data using the thermal imaging, where we took the 4 walls and the roof and got the mean temperature. It is wrong. We have to go get the black globe temperature. The globe is not available. So that limited my publications everywhere. Now 2 places. I went to the architectural engineering journal. They said your method with the equations we somehow tried. Now again, a huge list of comments to correct it because of that limitation. So we couldn't get that equipment. So my need is, if possible, it's better that we develop the national thermal comfort standard where even the air condition engineers, even the electricity, the energy, people could take decisions. We are taking decisions on people who are acclimatized for different climates. This is wrong. So it supports and it helps us in future where we will come for the energy issues, and we have to try and control air conditioning. That is my message. Air condition should not be the first decision when we are doing the building. It should not be the first decision.
Just one more comment about the buildings, what you said. I think it gives a real picture of urban, how do you call it, this concrete effect, heat island effect, but you have looked at it in a different angle. That's the important part. People measure it and tells about it, but you are looking at it from human health point of view. Thanks for that.
Thank you.
Thank you for your nice presentation. So in the steering committee, I think we told to do in 2 other regions also for the sake of comparing the study. So I think, because of the funding or whatever it is, you could not do it. But I would suggest to do it in your own, in other funding process or something. So then you can compare what is it really happening in one area to another area. Even within Colombo, you have done in only Matakuliye. So if you can select another area for the comparison's sake, it will give a better idea to understand the situation, I feel, but it's up to you and your team to do it.
Thank you. Thank you for the suggestion. Yes, it is. I need to do it, but the equipment is needed because with the available, because I was looking at the black globe temperature, And there is a personal thermal comfort monitoring thing. It's very easy to handle. Now at the moment we are using a tripod with the temperature, and that unit comes together. So even I recently asked from NSF whether I could go for gap filling grant or something. The equipment, I can combine it with the university grant for any research assistant support. But the equipment, it is much easier if I could get it and make it as you suggested to compare. Thank you for the suggestion.
I'm Professor Rajpaksha. So do you think this problem will be solved by introducing this high-rise apartment complex for low-income family groups?
Yes, thank you. That is a really a challenging question. Yes. One thing is the decisions. Because why they do go for these high rise because of the land price of the location. Right? So they can't put people into a high value land, putting up single story houses. So they'll go for the high-rise solutions. That is common not only in Sri Lanka, even India, Bangladesh, those countries. And they have done a lot of comprehensive studies, and it have gone up to the level of tuberculosis and all the diseases, which is silent in our case, would be the same. So, but there are ways. That's what we are doing in our studies. There is a step when you are designing. It's a modeling. It's not that what you draw as a square is put on the land and build it. It's wrong. The design process is wrong. You can do different variations and see the way the air flows. You can make it, and the way the shape, and also the north, east, south, west directions behave differently. Go and look at these buildings. All four sides are the same. That is the basics, the orientation. They are our guidelines. This could be done. It's not the problem of putting them into a high rise. It's the way it has been done. So there should be an innovative way to do that. If that is done, even they have put a courtyard at the center. It's all these buildings. Courtyard is a place where you get enough light. But those courtyards are very dark. They are very dangerous. And also the security issues would be high. So people do not value a courtyard because it's not designed properly. People put all garbage into it. So these behaviors of people, we need to put up catalyst buildings where we could change them. We could make them like to the building. So now they do not. So for your answer, yes, it could happen if it has been done in an innovative way.
Hi. Can you take a minute?
Yes, Dr. Arunantha. Yes, Dr.
Yeah.
Arunantha. Yeah.
Yeah. With the ocean warming, thank you, madam. With the ocean forming, it is expected that the marine heat wave events supposed to increase. During your study, did you come across any heat wave, marine heat wave events? Because mainly during the marine heat wave, the night sea breeze doesn't develop. So the night life used to be very uncomfortable. So did you come across any marine heat wave events during your study period? Then how you can, is there a correlation of the quality of life during the nighttime during?
I think I didn't get your question properly. It is about the marine heat waves, whether that connected with the data collection period.
Yes, mainly your focus was on the daytime temperature and increases, but what I am referring to the marine heat wave incidents during which the sea breeze doesn't develop and the nighttime temperature also very high and the humidity is also high, so the quality and the comfortableness is very less.
Yes, thank you
So,
for that
did you
question.
come across any heat wave events during your study period?
No, not during that period, but it was the peak hottest time which we have taken. But we have done the night time temperatures. Even the questionnaire said that it has an impact on their sleep quality. That is our future study, which is going to be start very soon. Thank you for that. And I do not know about the periods of marine heat waves. It would be good that if we could get information regarding that when we plan our next data collection cycle.
But I have seen your continuous temperature recording and also humidity recording, at least 2 graphs I have seen that. So yeah, I thought that you have recorded the temperature and humidity continuously.
Yes, we have recorded. But the analysis has not gone to that depth, so we have a huge database. So now even the questionnaire people said the night time temperatures are very high inside this building, so they have an impact on their sleeping quality.
So how long you have recorded those two parameters?
How?
Yeah, how long you have recorded the temperature and humidity during your study?
Yes, because our focus was to develop the thermal comfort standards. So that was for each person, it's close to 20 to 25 minutes. But the houses were separately monitored, the selected critical houses for continuous 1 to 2 weeks. Now the next study is planning to continue for few more weeks.
Okay, I understand. It is during a specific time in a daytime you go and measure. It is not a continuously monitoring for a week and week and a week. Okay, I understood. Okay.
Congratulations for your good work. This is the time to initiate some discussion, at least a kind of advocacy with the Ministry of Health and Ministry of Urban Development. I think Dr. Sudat is from Ministry of Health, previously worked there, so he definitely can make some advocacy work with the Ministry of Health to take this forward, because it leads to a lot of health issues as well as psychological issues. So it's better to initiate something without stopping with the research work, some action-oriented work at the moment. Thank you.
Thank you for that suggestion. So I request National Science Foundation take the lead role and connect us researchers. We have enough information, enough data, but we cannot go in. Even we are experienced in practicing, but we should be at least in think tanks or something like that to advise and to give our knowledge for the betterment of the country, because this is a public fund and I did my studies in Sri Lanka. So I look forward of a healthy built environment in this country, not an unhealthy built environment.
Yeah, actually, when I'm listening to your presentation, I thought of that this is not be the end. This should be the beginning, and there are more to be done. At the meantime, that I want to ask that because most of the houses you can't demolish and build up again, so you have to do some retrofitting or some modifications. Are there simple available modification systems that can be done, affordable to the people and acceptable? This that or
This is the study we are doing now. So we are doing computational modeling. So we have developed 10 to 11 retrofitting strategies based on, because these houses are so tiny, so we can't extend it. Only things we can do for the groups and the walls. So we are trying some modifications with local materials and insulation techniques, as well as some houses even having one opening at a lower level, another opening at higher level, take the stack effect and take the hot air out. That also has not been done. They are very simple techniques. And obvious basic science. I don't know why we can't understand that. Basic science, hot air, there is no way the hot air goes out. Hot air accumulate. So those things, even the general public, each of us, we own a house. We go and work in a building. We associate buildings. We also need to be global. Because in future, our aim, the objective is for the architect should be design a house for 27 degrees centigrade, not for 38 degrees. If that could be done, that's the greatest achievement for the energy footprint and everything of the country. Is this? That's true. Yes. Yeah.
According to our constitution, that the people's welfare and development is a responsibility of local government. Therefore, that knowledge should pass to that. But anyway, housing permissions are given by the local government. So therefore, so that actually this outcome should be shared with this at least by to the provincial level, so they can take some sort of action to disseminate to local level. So
we are very happy because we do not want anyone to die with a heat stroke inside a house.
At the same time, that I know that NBRO, they had done a similar study with respect to indoor air pollution.
Yes.
Yeah,
So
that is right. Premasiri.
Yes.
Yeah, Premasiri, because the thing is that those outcomes should be amalgamated to come out with it.
That's true. Yeah. Yes, and because we have NHDA, we have UDA, so a lot of architects are involved.
Yeah, I think that National Science Foundation
yes,
can.
that is, there could be.
I
had the intention and go and talk to NHDA, but then I thought, if it comes from a higher level, then it is even a support for academics. We are willing to give our knowledge, but there is no proper channel for us to communicate this.
Especially multi-story houses.
Yeah.
That UDA, NHD and all that. This the knowledge should be disseminated.
Yes, I saw it's a hot topic now to put up millions, billions to be
because at the same time that sound, those things,
same typology. Why is the question?
Yes,
and always question
those
what's the same.
Stress increasing some parameters, but anyways. Thank you.
Thank you for the questions. Thank you.
Thank you again, Professor Rajpaksha, for emphasizing on an alarming topic. Now let's move on to our fourth presentation. It will be delivered by Professor Pradeepa Silva from University of Peradeniya on comparative analysis of climate resilient biodiversity of home garden ecosystems in different agroecological regions of Sri Lanka. Over to you.
Good afternoon, everybody. I think without taking much time, I will straight away move on to my presentation. Shall I move this? Yeah, comparative analysis of climate resilient biodiversity of home garden ecosystem in different agroecological regions of Sri Lanka. That was the title of the grant we applied for. And here we are presenting the final the content. I follow the same content given by the NSF. These are the grant information, right? And we have the duration, of course, exactly 5 years, because we completed all the financial things at the end of 2023. So the project is no more functioning. and we got this much of finance coming through the NSF. And if you look at the project team, we have a huge team and a multidisciplinary team. Some the team members are from Jaffna University, and some are from forestry, and some the NGOs because we had to engage in community engagement. And if you look at the list of participants, some have become vice chancellors, some are now directors, and some have moved on to different positions. Right. So I will straight away go into the research problem that we had. So we were talking about home gardens. Home gardens are very common and popular land use pattern. So the problem is when we see something common every day, we don't tend to look at it carefully. So therefore, we looked at it carefully to find because there was no clear understanding of the contribution of different components of home garden, even though we know that it's a sustainable and biodiverse system, but there was no deep dive into the study of home gardens. So therefore, we took that challenge, and to answer to that problem, we took four parts. So first, we try to identify all the components of home gardens, biotic, abiotic, and then we try to locate the interconnectivity of these different components and also dynamics of these different components. And then we try to quantify according to their the contribution to become high climate resilience and to adapt to different climatic conditions. We try to quantify the contributions of different components. And once we identified most contributing components in home gardens, we try to put it into a model to classify home gardens to identify or identify their or classify them according to the vulnerability status of home garden. So if you look at different components, so first component we had 5 activities and 3 outputs, 3 activities, 6 outputs, and third activity, 3 activities and 2 outputs, and fourth objective, 4 activities and 3 outputs. So if we summarize the whole matrix of the project, it goes like this theory of change. So we had 4 objectives and giving rise to 12 different outputs. And then we came up with this final outcomes. The structure and functional variations of home gardens were described, and the relationships were established. Indices necessary for modeling were identified, and the protocols were developed. So that was the whole story. So going into okay, so the research outcome I'm presenting here is that home garden system with optimized resource use efficiency, climate resilience, food security, livelihood development, biodiversity ensuring ecosystem services, and functional connectivity to natural systems were described, enabling the promotion and replication. So that was the outcome of the whole project. And how we did that? So we selected 4 locations. I'm not going to give the details of my results here, but only the findings. So this is how we did it. So there were 15 ecological regions we captured in 4 districts. This many home gardens, this many hectares we perused. And we looked at these 4 locations and developed maps with the agroecological regions, and the locations of sampling are given in these dots. So the research outputs and outcomes. First, I described the research outputs under 3 categories. How we describe the structural and functional variations of home gardens in these 4 locations, and the temporal variations of home gardens, land use, and the extreme climatic events in these 4 locations, and finally the development of and validation of indices enabling the modeling of climate resilient home gardens. So in the description, we found in the 4 locations the tree cover and also the supply of different the food items supporting the household dietary diversity and also household food security. And we looked at the biotic and abiotic components in home garden. So when we look at the findings, so what we found was that home garden size is uh, uh, influences the diversity parameters above ground and also below ground, and it attributing to the variation of climate resilience. So the size, home garden size is the crucial factor. And also the location is also a crucial factor for the functional connectivity and variability of biotic and abiotic factors. So accordingly that we concluded that there was a high influence from above ground biomass of the home garden on the climate resilience, low influence coming from external factors like climatic zone, agroecological regions, and administrative demarcation. So why I highlighted this is because when we are talking about interventions of home gardens nowadays, people always go by the administrative divisions and the demarcations, but they are not the factors that we should look at or pay our attention on in proposing interventions to home gardens. So accordingly that we could primarily categorize home gardens or the home gardens that we surveyed into 3 categories: good, moderate, and poor home gardens, by looking at the diversity index, above ground biomass, and the strata level, and presence of animals, and also the faunal components. And from there, yes. So we could publish many articles depending on our based on our findings. So the blue color ones are full papers that we published in international journals, 3 international journals and 1 local journal. And others are presentations on the 4 different scientific forums. So these are the snapshots of those publications. And when we look at the second component, that is temporal variations of home gardens and the land use in these 4 locations, what we found was that there was a slight increase in temperature throughout the last 50 years we considered here. And also for the last 10 years, we looked at the aerial photographs. Actually, National Science Foundation helped us in purchasing all these photographs and the aerial photographs. So the idea that we got from these findings is short and long-term measures of drought adaptation at farmer level are required to avoid any potential losses in or deteriorations of home gardens. And also what we found was that tree cover was, including home gardens, were increasing in these 4 areas during the last decade period, except for 1 district. So these were the basic information that we found, and we published these information, the abiotic factors also in different communications. And then I will take you through the development of and validation of indices in modeling the home climate resilient home gardens. So we looked at these 4 parameters step by step. We went through these steps. So we assess the home gardens based on socioeconomic and environmental variables, and then identify important variables, and then the variables that can be used to distinguish good and bad home gardens or discriminate home gardens among each other. And also we by using all these information, we finally came up with the climate resilient index to categorize home gardens in interventions. Okay, so these are some of the findings. So we published this in scientific journals. So we came up with the climate resilience index by perusing a lot of information that we gathered. Okay, so finally, what we captured in climate resilient index is the absorptive capacity and the adaptive capacity of home gardeners. And then this allowed us to categorize the resilience of different home gardens in terms of climate change and contribute the resilience of home gardens to climatic factors or climatic influence. And then we could measure the contribution of home garden variables for resilience categories. So we quantify those aspects. And these are the results of that exercise. So you can see that for each and every district that we looked at, so we could categorize home gardens from moderate to average and poor conditions. And these are the parameters we looked at in categorizing. And actually, these parameters we came up with the list by looking at all the other parameters, biotic and abiotic factors that we investigated during our study. Right. So these are the publications. So again, blue color ones are full papers, others are conference papers. These are snapshots. All of them are except this one. All others are international publications with SCI. So the research outcomes, I will categorize the outcomes and describe the outcomes under 5 categories. So first, I will look at the give you information about the contribution we made to general public. Actually, this I have to thank the Postgraduate Institute of Agriculture for this, because they have identified certain research communications, and then they put it as a Hantana Essence publication for the general public, for the without technical jargon in it. So it's a general briefing for general public. So other than that, the contribution to research world. So what we did at the end of, because I said that we completed the research in 2023, and then what we did was that we developed a website, temporary platform, and then we handed that over to National Science Foundation for them to host in their website. Let me try whether I can go into website. It's not working. Okay, right. So yeah, it's okay. Yeah, so it's there. So all the data we collected and all the inventories we developed, all the information we gathered are housed here. So anybody can take this up and go forward from the place where we stopped. So that was our intention. How to go back? Probably. No. Would it? No. Yeah, cross it. Right. Yeah. Thank you. Right. So, and for the contributions that we made for capacity building, so to your left-hand side, the 3 individuals that got benefited from this research they are not straight sort of contributors to the project, but they got benefited from the project. And to your right hand side, they are the live wires of the whole project. Mr. Aishlo, he did his completed his MPhil, and also Ms. Kuruparachi. Both of them secured academic positions by now, and one is in Velas University, other one is Peradeniya University. So they straight away benefited from this project. And the knowledge-wise contribution for practitioners. So for practitioners, we came up with the package in our publications also, and also the general communications that we did in different fora. We came up with the directions for home gardeners, how to increase the productivity and the resilience, and also the how to enrich the food plate from the home garden products, and also how to organize home gardens and increase the level of resilience by incorporating different components aiming the substitution, replacement, management and expansion. Those are the 4 basic theories in managing home gardens, and also incorporating livestock and poultry into it, how to enrich or enhance the resilience. And for decision makers, there's a serious implication that we came up with from our findings. So the major implication is home garden intervention should be done specific to the agroecological region and specific to the location. So that is the biggest the message that we could come up with this our findings, because normally what we are doing at the moment is that home garden can be a sort of a tricky point or very easily accessible entity and easily accessible place in the community. So the people tend to give blanket recommendations or interventions, blanket interventions. So that should not be done. And also the perennial and annual crops plus animals. So these are the components that we have to always promote. Because it is not only the perennials, not only the annuals, that to make it sustainable and also climate resilient. So we have to have all the components into it. And also what we found was that the home garden, the shape of the home garden, functionality of home gardens are all built up with the perennials. The tree component is the most important component in home garden in making all this functionality of the home garden. And so the direct and indirect contribution to national economy. So if I look at the direct contributions of this, the findings of the project, so we could contribute to increasing the national food security, but by ensuring the whole household food security through home gardens. And also we have to appreciate the heterogeneity, not giving blanket recommendations as I mentioned earlier. So it is at the national interest level. And the model home garden, the process we followed led to identify model home gardens and the good home gardens. So that can use as a sort of a recommendation for the sustainable and resilient system to build up at the ground level. And we can definitely enhance the food basket and dietary diversity of the household by reducing the burden of malnutrition through the findings and recommendations. And from the indirect contributions, so we could foster environmental sustainability by delivering ecosystem services, that we can enhance ecosystem services through home gardens and increase carbon sequestration So it is a mitigation action, and also we can reduce the accumulation of primary greenhouse gases. So again, mitigation action. And sustainable land use pattern we can introduce through home gardens according to our findings. So that is increase ecosystem services, and also the resilience components of home gardens that we identified. There are 7 listed here. So these are important parameters that you should look at when you are encouraging or improving the home garden throughout the country. So the recommendation, so there are a few categories of recommendations we came up with. We communicated that to National Science Foundation earlier occasion. So strategies on intervention. So the intervention should match the heterogeneity of home garden. It should be site specific, and also we have to concentrate on perennial tree diversity to ensure the sustainability of home gardens. And the technological targets, because sometimes people might think that home garden is a traditional system. There are no technological interventions are needed, but not true, because we have to look at the techniques that we can target the expansion, replacement, and substitution and management, because these are the functions, 4 functions normally we look at. So in intervening at each level, we have to peruse the information with the technical information and get decisions according to the science-based decision. And also trees are the live wire in the home garden. So the modern carbon storage, we can take this forward in our technological interventions to identify how the actions can be taken, decision can be taken at the correct time to convert them to the source of income. And supporting strategies, network of supporting systems are necessary, because home gardening is not just a simple sort of activity. So we have to direct the owners in a way that you correctly do it and place it on the ground. And also for that, we need to do a capacity building activities. So we have given some policy recommendations there as well. So we have communicated all these to National Science Foundation to take it forward. And the future work beyond the project period, we did not stop there. I said that 2023, we completed all the things that we thought of doing for the project, but we continue to disseminate knowledge. So we engage in putting up some publications. So we contributed to book chapter. And also there's another publication coming from one of the postgraduate students. And also we try to come up with the project proposal. Many of the team members participated in this proposal formulation phase. And also that we can make this research finding go to a wider community. So that's why we put this into a website, developed website, and handed it over to the National Science Foundation. And the research collaborations that some of our team members went into different direction, coming where we began the home garden research from this the research that we completed. So there was some engagement from international donors, so World Agroforestry Project and Green Climate Fund Project, and also we contributed recently for a book chapter published by Taylor and Francis. So the agreement was signed for that, and it was accepted. It will come soon. And these are some photographs of home gardens. So depicting spatial arrangement of some of the places we visited. And this is from Jaffna. You won't believe that this is from Jaffna. It is so green. And this is another home garden from Jaffna. And Mathale. Ratnapura. And these are some macro fauna that we captured because we counted, we inventorized all the insects, macrofauna that we found in these home gardens. So therefore, there's a big the functionality and the connectivity that we found in different components in the home garden. So this is according to our model that we developed. So we try to validate our findings on paper by visiting those home gardens. So this is the best home garden, the good home garden in Mathale, Ratnapura, Hambantota. And we could not find good home garden in Jaffna according to the criteria that we developed, according to the resilience components that we identified. And this is a moderate home garden and poor home gardens according to our categorization. So after doing our the modeling component, we validate that by visiting those home gardens, and we found that our paperwork was sort of accurate. Thank you very much, and I take this opportunity to thank the National Science Foundation for funding and also the thematic area committee and the chairperson and all my team members, and also for listening to you all. Thank you.
Thank you very much, Professor Silva. Now you may take this time to ask questions, if any.
Thank you, Professor Pradeepa. It's not a question, it's a comment. The 5 projects we went through, and actually you and team have considered all the areas, not only research and how we are delivering it to the community and publications and things. So I see I was glad to be a reviewer for your project also throughout. So I'm really happy and wish you all the best for your research findings and their contributions to NSF.
Thank you, Professor. Thank you.
Can I come in, Pradeepa?
Yes, Professor Sumatipala.
Yeah, as we know that you did a good work. As I see, throughout the time, we were getting good reviews in your project, and I think you did it timely. I have just one or two things to clarify. You said the tree cover increase, or the vegetation or tree cover increase in 3 districts, one did not.
Yeah.
And how it happened is what, knowingly, or logically happened it, or, somebody, directed them to do it. Do
I
you have any
think,
idea?
that is a good question. Actually, we were also wondering when we look at the aerial maps and when we peruse it, it is because of the expansion of the building coverage. So that is the only reason that we could get. Because when we talk about the vegetation, it is not only the home gardens, but other vegetation as well, the forest area as well. So only reason that we could see is the expansion of buildings.
Okay.
Yeah. So, but good thing is that it happened only in one of the sites. Other 3 sites, it was increasing.
Okay. Okay. And then the second thing is you showed the, few photographs of Jaffna and you said green, but why you say it's not good home garden in Jaffna district? What is
Yeah,
the
because, yeah, yeah, yes, yeah. So, yeah, sorry for the confusion. Yeah, because it is not only the green cover that we looked at in our resilience index. There were many parameters. Actually, we did the principal component analysis in identifying the most important or contributing parameters in resilience index. So it is not only the green cover, but the presence of the other different components, biotic factors, abiotic factors. Because in our the research we looked at all abiotic factors as well, like water quality, soil parameters, all these things we measured. So according to those parameters, the Jaffna district, we could not find the home garden satisfying our parameters. Yeah, but they are great. Sure. Yeah.
Okay, thank you, and hope these your recommendations will be taken up by authorities to move forward. Thank you.
Yeah. Thank you.
Yeah, Professor Pradeepa, thank you very much for the presentation and information. I'm a bit troubled in asking this question from her because I came in the vehicle hired by her. So I have to go back to Peradini also.
So
So don't get cross with me. Right. Right. So you can understand Professor Sumutipala, the dilemma I'm in. Right.
Yeah, I know. I know.
The question, Professor Pradeepa, now you have gone through wet zone, dry zone, and intermediate zone.
Correct.
All three climatic zones are being covered. Were there any efforts made to look at carbon sequestration?
Yes, actually not measured though, but through the above ground biomass that we measured and compared.
Is it possible to do carbon sequestration from the data that you have?
I think so. Because we inventorize all these and we gave this information to National Science Foundation. Anybody interested in measuring carbon?
Not anybody. Can your team do that? I'm just asking.
Team
No, why I'm asking is that once
Yeah.
again, due to baseline data,
Right.
there are only few papers, one, two. I also contributed to one on very basically looking at carbon sequestration from a home garden. Now, if it covers about 15.3% of the land extent of the country, and that will give a real good value
Yeah.
in terms of understanding where we are.
Yeah.
And that will help. Once again, I'm always talking about the net zero and everything. That's fine. But to get that information, it's important. Since you have done the work in covering all three climatic zones, I mean, if you can work it out in such a way,
Yeah.
I'm not asking you to do new research to do it, but based on information available.
Yeah, that is a good suggestion, but not the team, because team is everywhere now.
People can work from everywhere and try to get it.
Yeah, because I had very nice two research assistants. They are also not no more there. One is abroad now in New Zealand. Probably he is joining online, and the other person is in again academic position. But it's
I
doable.
think it's worth doing this.
Yes. Yes.
Since this amount of information, again, you need more finances to get this information.
Correct.
Done.
Correct.
Right. So once it is there,
Yeah.
I think I recommend to do that
Mhm.
because that will definitely help the country in the future.
Yeah.
Thank you.
Yeah. That's a good suggestion. Thank you, sir.
The suggestion,
Perhaps Pradeepa,
Pradeepa, if you can get an undergraduate student project, if they can ask someone
Yeah.
to do that, then you can get
Yeah.
you have the data. And
Yeah.
only thing is to, if you can find an undergraduate student who is doing
Correct.
research, final year research projects,
Yeah.
they will be able to complete it. I think so.
Yeah, probably Professor Marabe can help me finding undergraduate students because I am from Department of Animal Science. Because yeah, you can help me, sir, in finding a good student for the calculation. Yeah.
Professor Pradeepa, I am Punyavardhana.
Yes, Dr. Punyavardhana.
While thank you for your gigantic work that have been done during last 5 years, of course, with the sizable funding from the NSF. May I ask a small clarification?
Yes.
With your recommendation, the very first recommendation was not to intervene or make any recommendation for home garden development without considering the agroecological setting of that prospective places. Can you give us one example
to why we should not do haphazard development or recommendation without
Yes.
considering the ecological.
Sure. Sure. Yeah. Actually, I can draw one example, Dr. Punyavardhana, from my own field because I am an animal scientist. So when we visited some of these home gardens, so to one of the programs that they are making interventions for home gardens to improve get rid of malnutrition. So they distributed some the chicken. So these chicken were not village chicken, suitable for setting in the home garden. So they were sort of culls from the broiler hatchery or somewhere. So they were panting and they were not doing any good to the household. So that type of blanket recommendations, and also if you look at the last few years of interventions to home gardens, sometimes they measure the progress of these interventions by counting the number of trees or number of plants they distributed or number of animals they distributed. But it should not be the way. The progress should be measured by the correct intervention you made and make these parameters how we could improve the home garden by using the parameters, not by numbers. And some of the home gardens we could see, Dr. Punavardhana, that they have distributed some cashew plants for different areas where the cashew is not productive enough in some of the agroecological regions, agroclimatic regions. So, and the soil is not suitable,
Very correct.
environment is
Very
not
correct.
suitable. Yeah. Yes, that is my answer to your question, Dr.
Yeah.
Punavardhana.
To spice up more that if you introduce fruit trees, I mean, you have to look at the ecological environment because for example, mango that are being grown in Jaffna Peninsula may not be suitable for Ratnapura.
Correct.
So like that, you have to, yeah, that's good finding. Thanks. Thank you.
Thank you, Professor Silva. The final research presentation of the day will be delivered by Professor Jagat Edrisinghe from University of Rwanda on assessment of spatial impact of climate change, geographic, economic, and social vulnerability on the plantation sector in Sri Lanka. Over to you.
It will cover the topics. Sorry. So thank you very much for inviting us. Our research is assessment of spatial impacts of climate change in the plantation sector in Sri Lanka. Okay, so I'm going through the structure given by the NSF. So let me go to the structure first. So this is the grant summary. I am the project leader and we received about 6 million rupees for 3 years, and then it was extended due to various reasons. And we have covered about 105 estates during this study, and the projections that we make is up to 2050. So the scope of the study is to get large-scale estates surveyed across all major growing regions in Sri Lanka with monthly production and input data extracted from estate records, whichever they had, which ran from 2004 to 2019. So this is our team. We had many from Wayamba University, and we have we had two MPhil research students. Both have completed by now, Ms. Hansini Ranjan and Kasun Somaratna. And we have in our team people from Rubber Research Institute, Tea Research Institute, Coconut Research Institute,
Department of Meteorology at that time, and also one from abroad. So if I tell you why this research matters, tea sector only tea sector taken alone, it's about 1.5 billion industry in this country, and the plantation sector is about 3 billion industry at the moment. So we know that from past literature, and others have already presented, that temperature is accelerating, rising from 1901 to 2017. There was about 0.67 degrees of Celsius rising. Various places, various numbers are given, but this is what I could find. So the plantation sector, why plantation sector is important? Because rural population is dependent on the plantation sector. It is the primary source of income for the rural people in the country. So why this study, and what this study going to fill in the literature? There is no district level evidence existed for how climate affects plantation productivity. We take several aspects of productivity, not only yield that we usually talk about. We take total factor productivity change, yield, profits, and technical efficiency, and then discuss how they have changed. Then prior work leaned on long-term averages and pass-fail p-values. Now, all of us do statistics, and we just say, okay, if something is above below a p-value, we say that is true, that is significant and not, but we are going a step further here. So climate's effect on technical efficiency, profitability, not yet studied very well. So that is why we have gone through this one. So if you take a few minutes to look at Sri Lanka's changing climate, and I have taken these from these numbers on the right from Department of Meteorology. This is the anomalies predicted for 2050 projection, high emission scenario, about 1.89 degrees Celsius minimum temperatures to rise, and about 1.74 degrees Celsius maximum temperatures to rise, and the rainfall is also to increase by that amount. So we have a long-term warming in the country, accelerating by year. There's a cumulative rise, average temperature rising cumulatively, hot days increasing, all affecting plantations, agriculture in general. And there is asymmetric warming, minimum temperatures rising faster than maximum temperatures at the moment. And given all these things, geographical variability on impact, we think that one size fits all approaches is unlikely to be effective. So therefore, we predict district by district. So if I go through the research problems and objectives, so this is our study objectives. Given the geographical variability and impact, as I said before, we want to check how it is affected, how it affects various parts of the country. And the old way that we have seen basically in research is that we check how climate affects yield or climate affects productivity or whatever, and check whether it is affecting significant or not. But from this study, we are going to look at a new technique of estimation called Bayesian calculations. And with that, our aim is to model, predict, and impact, model and predict the impact, and also assess the spatial variation of climate impact on specifically tea and coconut in this research. So research outputs and outcomes, if I go quickly to how we have done this research, we collected field data, monthly production, and input data from 38 tea and 67 coconut estates. We collected monthly data from 2004 to 2019 across all major growing regions. And our target is to predict for 2050 horizon. And then climate data was downscaled, obtained from World Climate, because we did not have climate data. Of course, the meteorological department climate data is so expensive that we could not purchase them. And we calculated Bayesian Markov chain, Monte Carlo chains. From that, we estimated a stochastic frontier regression models estimated via Markov chain Monte Carlo with 40,000 iterations using two kinds of software, Stata and bias. And then this predict this 40,000 iterations. That means we have 40,000 data per one variable. So 40,000 iterations were spatially predicted geographically by using geographically weighted regression, which projects impacts into every growing district of the country. So this is what the study covered. The study, the field service, these dots represent the states that we have covered. And these are the growing regions in the country. We know that middle graph is tea growing areas and the rightmost graph is coconut growing areas. Then we try to cover all the areas possible within the time. So what we have done is, it's not just a regression exercise. What we have done is we have calculated multitude of models. We had 6 specifications listed here: linear fixed effect, linear random effect, linear pooled, quadratic fixed effect, quadratic random effects, and quadratic pooled. And then these 6 specifications were run with 4 outcomes: yield, profits, yield, profits, total factor productivity, and technical efficiency. So 4 outcomes multiplied by 6 specifications for 2 sectors resulted in 48 models. And this is the candidate model selection process. After running all these 48 estimations for 40,000 iterations, we selected the models that we are going to explain using Bayesian model probabilities. So that is how the research was carried out. So this is a summary of what we have done. We have economic mechanics happening in the plantation level: technical efficiency, total factor productivity, profit, and also yield. And we put environmental catalysts of climate anomalies. What we are going to do here is we are not going to relate temperature and rainfall directly into all those technical efficiency, yield, and all that. We relate the climate anomalies rather than the direct variable itself. So then we go for Bayesian MCMC iteration, and the impact for the 2050 is predicted by for each indicator predicting for the future climate and predicting for the current climate, and then deduction, we have the impact. So this is in a nutshell what we have, what our results is. Right? So this is the final outcome of the result. Before I go into detail in every aspect, you can see these are probabilities of negative ceteris paribus effect, meaning that having everything else constant, when minimum temperature changes, for example, when other things do not change, when minimum temperature changes, this is how, if you go through this row, when minimum temperature changes, how it affects the various aspects of tea and coconut. So these are probabilities of negative outcomes. So what we are saying, now we can say that, okay, temperature increases. What we know is when temperature increases, tea yield will come down. That is what we predict. That is the usual way of prediction. But what we are doing here is we are giving a probability or risk. We are giving a risky situation. We are measuring the risk that is available in the country. So we say that if I take, for example, minimum temperature, there is 98% chance because of a change in minimum temperature, 98% chance, very high chance to reduce yield. So if you look at technical efficiency, there is 70% chance of reducing yield. But remember that there is also, when you say 70% chance of reducing yield, there is a 30% chance of increasing yield as well. Right? So that is the beauty of this possibility of using Bayesian techniques in estimation. So you can see various aspects of minimum, maximum, and rainfall anomalies. What we have used is anomalies, although it's not worded that way, but minimum temperature, how it changed from overall mean. So the overall mean that we have used is 1970 to 2005 world meteorological average, and from the actual temperature were deducted. Sorry, the mean was deducted from the actual temperature to get the anomalies, and we are running the anomalies, not the actual temperature. So this is the final outcome of the research. So if I deep dive into each aspect separately to show you how these were calculated, how these probabilities were calculated. So if you look at total factor productivity, some of you may not know what is total factor productivity. So this is not just productivity, this is the productivity that comes when all other factors are controlled for. This is productivity increases over time because of changes in technology and so on, right? So therefore, we look at that from monthly data from 2004 to 2019 for 38 estates, and we find that probability of negative impact on total factor productivity from maximum temperature is 82%. Probability of negative impact of rainfall is 76%. So no one can say that definitely there will be negative impact on rainfall to the factor productivity, but there's a probability. But the important thing is minimum temperature plays a very small role. So rising maximum temperature and rainfall are the clearest threats to key total factor productivity when other things are controlled. But if you look at for 2050 projection, these are regression estimates, what we have on the left. But when you look at for 2050 prediction, there is a chance of positive impact on tea yield by 79%. Probability of net positive impact. That means, but although net positive impact, that means there is a 21% chance of negative impact as well. So when that prediction is taking all these together, not individually, one can say, okay, maximum temperature reduces total factor productivity, but taken together, they predict a positive impact. That is the scenario at the moment with T total factor productivity. So given the graph, to show you what this is, a estimation run from 40,000 iterations of a graph. So what we are doing is, this is the beta or the coefficient of a variable. Now this coefficient of the variable is run for 40,000 times. So what we have in this picture is the population distribution of that variable. So the red line indicates the 0 point. To the left of that is the probability of having a negative impact. So same things are projected here. These are real graphs came out from the estimations. So if you look at technical efficiency and yield both together, technical efficiency is how efficient you are in cultivating in the tea sector. Average technical efficiency that we found in the tea sector is about 88%. That means without expending that much of expenses or that much of input, you can increase efficiency by another 12% in this country, according to the findings. So it ranges from 68 to 96%. Some estates were very efficient, some estates were not that efficient. So average came to 88%. But when you look at the minimum temperature effect, the night temperature, there is a 70% chance of hurting technical efficiency in the country. And on the right hand side, you have the yield output. If you look at the minimum temperature, we can see that minimum temperature is the culprit here in affecting yield and productivities of tea. There's 98% chance, almost 100% chance that the minimum temperature will hurt tea yield. And we see that 150 to 263 kilograms per hectare per year predicted loss. Per hectare per year predicted loss from the output that we received. And chance of negative impact by district is it moves from 72 to 91. So I will show it later. What I say is it depends on the district that the cultivation is, of course, that is the scene. So yield is the clearest area of concern for minimum temperature anomalies show a statistically significant negative relationship with the TE, right? So that is what we find from technical efficiency and yield impact on technical efficiency and yield by the climate anomalies, right? Remember, I'm talking about climate anomalies, not climate itself. So climate anomalies are the way, I think that is the best way to measure climate change. If I understand correctly, that is how I was told. So if you look at profitability and also the sector summary in this slide, profitability, conventional p-values show no significant effect because when in this distribution, when 0 falls in between, we can say that it is not significant. But to the left of this red line, you can see very big mass of the distribution. So that says that there is 73% probability of real terms profit decline is there. By 2050, of course, the prices may change, the things might change, but still, according to the current situation, if the profitability in the 2050 would be less by 73% in the tea sector. If things happen nicely, that is okay. But there is also chance of some 27% increase of profitability as well, right? So there's a risk. So why I'm showing a risk is rather than telling a policymaker that okay, temperature increases, this will reduce. We are giving a risk so that anyone can take this risk into consideration in making decisions. So tea sector at a glance, if you look at the final outcomes of tea sector, total factor productivity likely positive by 2050, but 21% chance of reduction. Technical efficiency slightly positive effect. Negative impact is very low. Possibility of negative impact is very low for the technical efficiency. And for yield, it is almost certainly negative. That is what we have to understand. For yield, it is going to be negative, most probably. Profitability predicts decline with meaningful regional variation. So that is what we will see. I will come to the regional variations in a later slide, but for the time being, let's move on to the coconut total factor productivity and efficiency. The coconut sector, how the climate affects total factor productivity and efficiency. So if you look at total factor productivity, probability of a negative price, negative using ceteris paribus effect, I'm always writing that to show you that when other things do not change, right? So if everything is changing, this might not happen. This is economics, right? This is social sciences, not direct science. So things might be different, should be understood differently. So this is minimum temperature. Again, it predicts almost 100% negative effect probability. Rainfall is also high. Maximum temperature has a 36% chance of giving a negative impact. So probability about 98 to 99% probability of net negative TFPC or total factor productivity impact by 2050. It is the clearest downside risk found for coconut. Now the middle graph that we show is there are three distributions. These three distributions are from three districts, right? Main coconut triangle. So why I put that here is to showcase that irrespective of the district, the distribution is same. So distributions overlap, right? So impact of climate change on in terms of total factor productivity, distributions overlap. So therefore, the impact would be similar for all the three coconut growing districts. But if you take about technical efficiency, we see a positive impact in the technical efficiency case. So if I go to yield and profitability, we see a nonlinear story. Now, if I go back to what I said, we said we had estimated 48 models, and the models were selected probabilistically from the computer. So we did not say that okay, this normally people say that okay, climate should have a quadratic effect with the climate increasing, or let's say temperature increasing, yields might rise and then come to a maximum and then drop. That is a normal expectation. But the models, when we added the quadratic term, some models were significant, some models were not significant. That is based on data that we have. But for coconut, we had a non-linear models were significant. So there is zero in terms of yield, there is zero probability of net negative effect by 2050 in coconut, according to the data that we have collected. About 192 to 288 nuts per hectare per year would increase, according to what we see. Rainfall trends negative, with 100% rainfall has an impact than temperature. Combined with the other variables, the overall probability of harm falls to 6.5%. So there is very low probability of affecting coconut yield by 2050, right? So you can predict to further, but this is only up to 2050. So profitability, if you look at profitability of coconut, overall probability of a net negative effect is 15%. And these are the three graphs. You can see for the yield, we have graphs are not overlapped. They are different. They are highlighting that they are differently distributed with different means. And there is 13 to 26% negative impact probability by district. So district impact is varying from 13 to 26%, although we say that there is no effect on climate change on coconut profitability, right? So if I take the three things, all the things into one slide to showcase what we have found, total factor productivity by 2050, you see a positive, but with a 21% negative risk. But coconut, we have the impact is negative. For coconut, the impact is negative. There is 98 to 99% negative risk, right? So therefore, it is possibly negative, right? So for coconut sector, technical efficiency is slightly positive. Uniform gains, and both for coconut and ghee, it is positively. It shows a positive side. Yield, negative. It is driven by the minimum temperature or the night temperature. And coconut has a positive effect. It is non-linear, but it's variable by location. And profitability has a negative impact with 69 to 75% risk by district. I will come into district distributions in the next slide, and positive, but the profitability is positive with modest risk. And key climate driver for tea. Key climate driver for tea is maximum temperature and rainfall. And for coconut, it is minimum temperature and rainfall. There are regional patterns to be discussed. So if you look at all this whole picture, put them into regions of cultivations. I took coconut for only the three major growing regions, not the all growing regions, but tea we tried to have all the sections, all the areas. So every modeled outcome, that means total factor productivity, technical efficiency, yield or profit, broken down by growing district, we show that from green you can see low risk. If it is red, it is high risk. So you can see for Matale district, yield and profit show high risk. So all the districts, we see that yield and profit is high risk for tea, right? But when it comes to coconut, the yield and profit is low risk, but the total factor productivity has a high risky possibility of going down. So, so for tea, what we see from this slide is for tea, no district is safe on yield or profit. Risk is everywhere, right? Risk is everywhere. So we can say that, okay, tea is going to be affected by climate change, even though total factor productivity and efficiency risks are low, yield and profit has a high risk probability. Coconut total factor productivity is the only universal downside. But from the data that we have gathered, we cannot see coconut being harmed that much by the climate change in the future. So if I go to what we have, that is what we have found from this research. So these are some things that we have completed: publications and capacity building. We have about 21 publications with papers and conference papers. 2 MPhil degrees were completed. These are the 2 students, Mr. Somaratna and Ms. Ranjan, and both are now migrated to other countries for PhDs. Hopefully not migrated, gone for PhDs. One is in Austria, one is in New Zealand. And this is publications and capacity building. And also we had 8 undergraduate students completing their research and submitting thesis. I forgot to type it here. And from research to real world impact, we have district level predictions for 2050. So this will give estate managers, for example, plantation companies we have 23 regional plantation companies, and these companies have plantations everywhere in the country. So they don't have to have one policy to attract to mitigate climate change, because we now know where the climate change effect is maximum. But unfortunately for tea, everywhere is affected. But for other things, factor productivity and all these things, so estate managers, plantation companies, regional planners can use this information. The findings and the 6 recommendations that follows in the next slide are positioned for direct use by Tea Research Institute, Coconut Research Institute, and plantation companies. And community and academic, we have publications. We have developed undergraduates, postgraduates, and academic contributions were made. So if I go through the why these findings matter nationally, the economic impact, because tea and coconut are vital export earners underpinning national economic resilience. The evidence base helps protect that resilience. I know that, I don't know, there are private sector people here, but tea sector, although prices are going up and all that, people are converting to coffee. Now, if we say that, okay, climate is affecting tea also, and that will accelerate the thing. Now, it's not because tea is not profitable. Tea is highly labor intensive, and coffee is coming up. There's a trend in coffee, and I've met someone from Coffee Association. He said he can get 30,000 rupees per kilogram of coffee that is produced. So definitely, if at the time being, government does not allow conversion, but when it happens, finally, it will go. So that is the economic impact. And then food security, tea and coconut are components of Sri Lanka's agricultural output, not only from consumption point of view, but also their income point of view. The tea and coconut are in the rural areas, so that will affect their incomes, and their food securities will be affected. And identified negative impact risks underscore the need for proactive adaptation. You all know that. Strengthening the resilience of national economy overall. And employment and livelihood, both sectors are major rural employers. So we know how tea and coconut are employing our rural sector. When these things die in the rural areas, there will be exodus into urban areas, and the previous research about heat stroke and everything will go up when rural people come into urban areas and slums are developed. So that is why we need to protect our rural industries that are in the rural sector. So regional equity, district level results let policymakers target region specific strategies rather than one size fits all. And also there are policy guidance. We took something special, I think. Bayesian uncertainty quantification was never done in this kind of thing previously in Sri Lanka at least. So that is why we think this is good. So these are 6 priorities for adaptation: regional specific strategies, invest in R&D. I don't have to tell that, but everyone here agrees on that. Then promote sustainable practices, water efficient irrigation, soil health, climate resilient crop varieties, and all these things. And diversify crop varieties if possible, because we are talking about profitability. Without profits, a business will not run. So whatever we say in science, without profit, the business will die. So if we say that by 2050 profit is going to decline, some method should be there to retain the profits, maybe by diversifying crops. Enhance technical efficiency by training and extension services to help farmers capture climate change potential efficiency upside. And government support, policy framework, subsidies and all that can be designed based on where they are needed. So we have opportunities for collaboration, fine-tuning climate models with microclimatic and soil level data for sharper. Now, what we have estimated is what we call as Ricardian regressions. This is Ricardian regressions are usually done for cross-sectional data, but we had a panel data, time series panel data. So we ran a Ricardian panel estimation. But when you run Ricardian data, you need soil data, you need this microclimatic data, but we can improve on that if we collect them. Then dynamic modeling on how climate productive relationships evolve across different crop growth stages, that is possible. And assessing economic viability and cost effectiveness of specific adaptation technologies and various things are there. What we can do with collaborations with maybe CRI team. We have team members from CRI and TRI and all that, and we can improve on this further. So that is about my presentation. Thank you.
Thank you, Professor Edrisinghe. Now we can proceed to the final discussion session of today. If anyone is having questions, you may ask now. Or any comments.
Can I come in for a comment, please?
Yes.
Yeah. Professor, now I'm just thinking, it is just a comment. Now you used data, the med data from the med department was expensive, you said, right? So, and also you said you are using not the real data, but anomaly. When you use anomaly, if the data is faulty to some extent, the anomaly becomes worse. So your research fully on the data. So data, if data is a problem, your results will be a problem. I'm not saying that your results are risky, but I'm just giving my comment. Maybe not. So my comment is that med department data is expensive, meaning that med department runs with the treasury money. When I was there as the chairman, I had a negotiation to release some of the data for at least for research purposes, national research. Their point was that data is they take it and sell out. But now maybe the NSF should have a discussion with the med department to have some method of getting data, valuable data for this type of research, because this is very important. It's a national thing, and this work is very good work. And if something goes wrong with the faulty of data, it's a sad situation. That's my comment. Then of course you could have taken some at least few things and test the ground truth. Actually, ground truth is very important. So I mean that's my comment. And the second comment is that when you say that tea might go for coffee, I have a comment here. There's a person here in Australia. He wants to do some coffee cultivation because he's saying that he can produce a lot of foreign currency for Sri Lanka. But he is looking for land. I hope that they will, the authorities will not give up tea for him. Other lands can be secured for his work. I think he is in Sri Lanka now. Hopefully, the government. He talked to the foreign minister when he was here. So hopefully it will not go in the direction of removing tea and putting coffee, but hopefully other land will be provided for him. Those are my comments. Thank you very much, Professor, for your fine presentation.
Okay, can I come in? Okay, about the data, he used
Yes.
data downscaled gridded data from WorldClim. So those data, WorldClim data is usually used for research, academic research. That is why we have used, and we tried to get down data from meteorological department, but it was very expensive. At the time, NSF, I think, did not have money to spend that much of money. So we had to rely on the data that was downloaded from WorldClim. That is true, but the WorldClim data is worldwide accepted data set, so that is why I use that. And for the coffee one, I think there's a coffee trend. Everyone can see in the when you go around the country, there's a coffee trend. And very recently, Food and Agriculture Organization proposed they are going to present this in Rome for business to bring businesses to the country. So there was a coffee proposal, coffee processing actually. To process coffee, we do not have that much of cultivation in the country for the extent of processing that was proposed. So then cultivation is also proposed in that that will be presented by the government. So there will be coffee coming if that proposal is accepted by a private person from abroad. Then there will be investments, and then there will be coffee cultivations to come up. The only problem is the tea plantations are the suitable areas for coffee cultivation as well. So tea cultivation at the moment you are allowed to convert the non-planted area or areas that are not profitable. That is, I think the government might take a decision. I don't know, but if that happens, then coffee is a lucrative industry from at the moment.
Yeah, perhaps now, is a Sri Lankan who was thinking of this. He imports coffee, which we know here. He has coffee shops all over. And he was saying that he can come to Sri Lanka, invest on coffee cultivation, and bring a lot of foreign currency. So hopefully he can find land somewhere. Government will provide him land from, some other areas, except tea maybe. That's what I'm thinking.
Okay, thank you very much. I'm Buddhima Rembe once again from Peradeniya University. Thanks for the presentation. I have a few comments just to clarify my mind. You have chosen RCP 8.5 as the scenario to do all these analyses. Now, that is the worst case scenario, right? So I think it's important that you make all these explanation. You have to keep that in mind and make the people aware that all these risks that you mention is based on a worst case scenario. And my question is, did you also try it at least at RCP 4.5?
High emission it's high emission scenario. So on the right side?
Yeah, high emission scenario. That's right. My point is not that. That's fine. So explain that. But did you made an attempt to look at it at RCP 4.5, for example? No, right. So it's important that you always mention that. Otherwise, people will get a different idea sometimes, right? It's good. I mean, not to say it's wrong. And one thing is, again, you know that with AR6 of IPCC, AR6 now go for shared socioeconomic pathway, right? Is it possible to do that analysis using the data that you have?
We have only data that is production data from estates and the output data, whether it is yield or profits or whatever.
Okay. So
And
it
from
will
that
not match, right?
match it.
It will not match. Okay. I do understand because this is how the proposal was approved. But the line of thinking changes when it comes to climate change always. The third point is, Professor Matipala, you said that Med department should release data free of charge at least for research. Actually, in 2013 budget, 2013, in the budget speech, it was there. Budget speech says that from this year, the med data will be given free of charge to research. But it didn't work. And the Director General at that time is seated behind me right now. Okay. So anyway, there are issues, of course. It's not easy for med department because when you find their mandatory activities and so on, those issues come up. So I'm not trying to say what you have done is justice, but that's the only way out for you, I think, to get this work done. Well, those are the comments. I think in your explanation regarding impacts, there should be an interpretation at the end. What you have to understand is P, you will very well know much better than me also. When it comes to harvesting or plucking, tea is plucked once in every 7 days, for example. So the stress on the plant is maximum. So the impact of climate change on that type of a situation of a crop where the growing parts are being removed every week is a massive thing for a crop, unlike in the case of a coconut. So I saw you had a very good comparison chart, but in that comparison chart, if you interpret in your report, it's better to incorporate that component. Otherwise, people might start thinking different, right? So
no, he actually showed the negative effect.
Yeah, you actually showed?
Negative effect on all areas.
Yeah, okay.
So
Right.
that is
Maybe I got it wrong, but my point is it's good to get that thing clear.
Grain yield and profit.
Okay. Okay. I think I missed that. Yeah. Okay. I think I now understand what you're trying to say. Okay. Right. Those are the comments. Anyway, thank you very much. And I'm great that it ended up at this level. Thank you.
Just adding something to Professor Marabe's comment, not the data. So this is a model, no?
Yes.
So I think there should be some provision to input other data also. Then you can get to know that clear picture with the other data. For example, he said, so you use RCP for 8.5. So there should be some provision to input SSP 4.5 and 245 and 585. So then you get to know that the clear information.
I already have the model, so I just have to put the data.
So data is available, no?
Yeah.
SSP.
So for this analysis, we only use the high emission scenario, as he said.
Yeah.
But if it is needed, I can quickly run the regressions
Model,
again.
no? So,
not big thing. Yes. Yeah.
Maybe another 2 years.
Yeah, this was done in 2022.
Yeah.
Yeah. Dominant, yeah. Okay.
Thank you, Professor Idris Singha, for sharing your interesting and valuable findings with us. As we come to the end of today's program, I invite Engineer Mahesh Disanayake, Head of the Research Division, National Science Foundation, to deal with the concluding remarks.
Thank you. Thank you, Ms. Sarani. National Science Foundation being a premier funding organization in the country, we always respect our researchers, and also we try to facilitate and support our researchers in maximum level. This NTRP on CCNND, this project was initiated in 2016 and initiated project in 2017. Originally planned to disseminate funded 90 million, nearly 90 million planned to 5 projects. But with some constraint in the country, maybe COVID and travel restriction and also a fund restriction. So we could only fund 53.17 million to the all 5 grants. That is nearly 58% from the total grant value. And all project PIs, they have spent almost all their money. That financial progress is nearly 97%. And we had some financial constraint, but we tried always to give our full support to our researchers there. And all project they have now successfully completed. But with our research coordinating committee, we had to do some amendment to the initial proposals with those budget constraints and other constraints, because travel constraints was there, some fuel constraints was there, so that some of the project we had to made some amendment to the projects and then get board approval for those projects. Accordingly, we have changed the budget also, that one. So that we have not curtailed any funds or any budget by purposely or agreed. We have sent all the funds as they have requested. Only one project they have initiated somewhat later, maybe 2019, Professor Indrika. So that project also initially 11.03 budget was there, but she has requested only 2.6 budget later, and we have sent 2.6%, nearly 25% from the total budget. And we come to the output and outcomes. National Science Foundation, we have two performance indicators, key performance indicators. That is, one is knowledge creation, and other one is the capacity building. So from these 5 grants, we had 2 PhDs, 7 MPhils, 2 MScs. That is totally 11 there. And then there are some undergraduate projects also they have supported through these projects. And we have 20 publications and 41 communications as knowledge creation and capacity building. So because we always try to achieve value for money, there is a tagline, value for money, and knowledge creation is must, because always we are thinking about the research commercialization, but I think we have today witnessed that research commercialization is not just complete the research and start a business with the profit and loss. Actually, it's the business with the people. So today's all 5 projects, they have a lot of knowledge created, and those knowledge are required to our society, our country, making policies and to make some comfort to our people, to uplift our people's conditions and also conditions of the country, especially forest and our other sectors there. So that we think that as a National Science Foundation, all 5 projects or PIs, they have done their maximum effort to complete their project in a good manner, because we know that all PIs were not in the AC room, so in the university, maybe in the sea, maybe in the forest, maybe in some low income settlements, maybe in some other areas to do these projects, so that they tried their best to do that one. So we would thank them for their contribution to the knowledge creation and capacity building. In capacity building also, actually, we expect more capacity building through this type of research, because we do not have more expert on these areas. We need to have more and more expert on these areas. Then only even we can take a good decision in the national level also. So that is there. And we will compile all these reports as a one report, and we will submit it to our board of management. Once we submit to the board of management, we will officially conclude this NTRP on CC and ND. That one. But even though we officially end up this project, we will not end up the research work, because always we would like to continuation of research. There is no end up of the research. There should be a continuation of the research, even though our project is initiated. So that National Science Foundation has initiated gap filling research grant in 2024, that if some researchers want to continue their research, they have to do some small research part in there. We will invite them to continue that one. For example, now we have seen there are 2-3 research emerge from Professor Pradeepa, even Professor Indika also. There are some gaps they need to complete some little part, so that we can invite them to do their next level research part, to complete that little part and do some publication and make some new knowledge creation. So that we will invite you to do that part. We will give nearly maximum 2 million for 2 years to that part. So that is one thing. And also Professor Di Costa mentioned that they have some automated rainfall measurement units with them, and National Science Foundation will see what we can do, because we need to continue that part also. Because I remember that in 2024 I attended Global Research Council meeting in Thailand. So at that time Japan, they mentioned that we have to have a long-term research, because actually we have a short-term research just 2-3 years. Even we don't have mid-term research. Long-term research just like a 10 years. So in that case, actually they have talk area as a climate change and natural disasters. They say that we have to have a research on how climate change or natural disaster affect to the human beings, how it affect to the animals, how it affect to our environment, forest, like that. But actually at that time our expert already has identified those areas, and our project was going on. I have mentioned that one to them. So that means we have seen the future. And I think our chairman also here, our additional director also here, we have to initiate a new program, just like some long-term research program on these areas, because now El Nino and recently Dita was there. So we have to have more data and more research on these areas to solve those problems or to face those difficulties, so that we will get our board of management approval to initiate new research, and we will discuss with our expert on these areas. And finally, I just want to thank all our researchers, because their hard work, and they have done justified to their all research, for their valuable contribution, and their team members. And also, I want to thank Professor Sumati Pal and our committee, because actually they was last 10 years, they was with us, all are very busy people. They have a very high workload, but even though they have physically and online, they will work with us, and they have guided us to do this project. So their guidance we request in future also, that one. And also, I just want to thank present chairman, present DG, and present additional director general for their support during this project, and also previous chairmans, board of management, and DGs and additional directors for their support. And then when this project is continuation and executing, so I just want to remind Ms. Dilani Jayavira and Ms. Madara Varnakulasuriya and Engineer Sureshani Varnasuriya as the coordinators. They have progress this research in fruitful manner. And lastly, Engineer Sureshani was the coordinator, and she has arranged all other things to conclude this one. And also, I just want to thank all our RD staff members for their support during this project period. At last, we could have achieved our project objectives, even though not as we have planned, but as justified to what the money we expend to our research. And finally, I would like to thank all to contributing their valuable time on behalf of National Science Foundation. Thank you very much.
Thank you, Engineer Disanaika, for your valuable words. I now officially conclude today's program, and I wish you all a continuous success in your all future endeavors. And we wish you a pleasant afternoon and invite you to join us for lunch. The lunch is served outside. Happy afternoon. And also, I thank you all for joining online also.